Yeah.
Super Monkey Ball was here, and then it's just like your dates.
Yeah. And you know what I might do? I might. Oh no, I'm not going to do it. But it just gave me an idea to spray paint somewhere in London. And then the only people who would know who did it was the server.
Yeah, I didn't that on there. I don't know this. Saved all the champagne, by the fact your marriage is saved. Those 4 words of silver or the champagne. Told you that before.
Okay. Are you guys watching something? What's going on here? Why is it so quiet?
We were all just waiting for you.
Ah, here I am. What's up?
Hello. Yeah, we were just wondering whether you think the Earth's a globe.
Earth is a globe? Oh shit, I've been there before. I'm not gonna answer that. It's too messy up in here.
So you do think it's a globe?
No, I'm saying it's too messy up in here. That's it.
So you think it's a globe?
No, I think it's a place where a lot of wild ideas are being thrown and people get salty over this topic, so I'm not gonna say anything.
Well, see, the thing is, you're already telling me by not telling me.
All right, whatever. But I'm not saying it, right? If I'm telling it, then
Yeah. Well, because if you're a flat earther, you would just say, "Oh, yeah, I'm a flat earther," and then, because that would be the end of it, right?
yeah, I'm just here for the salt.
Unfortunately for globers, they come looking for our salt and leave with their own.
Oh,
Often. So where are you from? You sound like you might be Portuguese or Brazilian or something.
who, me?
Yeah.
Oh, no, I'm from the Middle East.
That actually makes sense. Kuwait.
Crypto. The amount of times I've heard you try and guess someone's nationality. I mean, maybe you get it right all the time. I've never ever heard you get one right, or even come close to getting one right.
Oh.
You,
I get it
maybe
right
you
about
get it right all the
75%.
time. I've just never heard it. It's stuck in my mind from a while ago that you never get it right, and then you've just done it. There, it's like you're half the world away. But maybe you get it right all the time. I don't know.
Nah, I
Half the
mean,
world.
if I was confident, I would have told him you're from X place. But I wasn't confident, so I just kind of threw out a couple of random countries. But normally I'm very good with kind of Anglosphere countries
Yeah,
or
Australian.
European countries.
I can guess Australians quite easily.
All right, can you guess which country I'm from? I've just told you I'm from the Middle East, but can you guess?
I'd guess at Lebanon.
No, I'll give you a hint because it's not easy, right, to guess. But okay, so it's in the Arabian Peninsula, and this country has been through a civil war for nearly 8 years now.
Syria, is it?
No, nope.
I don't think that's in the peninsula, is it? So you're talking about.
Okay,
I mean,
another
my
hint,
first.
which is so easy. So this country is doing some stunts in the Red Sea, like political stunts.
Oh, I don't know.
Yeah, someone in the chat already knew. Okay.
Yeah, I don't know.
Yeah, I'm from Yemen. Yeah.
Ah, Yemen. It was on the news recently, wasn't it? Like today or yesterday.
Well, nice guess, Amish. Yeah.
Yama. Have you noticed how the two countries to the south of Saudi Arabia both sound like Jamaicans are saying?
Yeah, Oman in Yemen.
Oh, man.
Yeah.
Yeah, man. Yeah, I lived in Saudi Arabia when I was younger, but I've never been to Yemen.
Oh, you've been to Saudi Arabia. Interesting.
Yeah, I lived there when I was younger.
Ah, cool.
No, it's not cool. It's the fucking hottest place I've ever lived. Crazy.
Were you
hot.
in Jeddah or Riyadh? Which part of Saudi?
Well, both Jeddah and Riyadh. We're also in another town. We lived in three places, but it was Jeddah, Riyadh, and somewhere else.
All right.
Yeah, it was nice. I was a bit too young to remember it fully, but I remember bits.
So was it like for how many years?
A couple.
Oh, so I assumed that you might like speak Arabic a little bit, but nothing.
I did used to speak Arabic reasonably well, but I've completely forgotten it now.
That's sad.
Like I know like yalla and like the odd word, but I couldn't like have a conversation anymore.
Is 17 sabotage?
Yeah,
There you go.
sabotage.
That's what I know. That's all my Arabic.
That's interesting. It's a specific number too.
Yeah.
Was that like your address or?
No, because for the last 10 years I've been a croupier dealing to Arabs, and for some reason,
Okay.
and they all like to play number 17, and they stand at the
Wow.
table going sabotage, sabotage. I'm just ploughing loads of money on number 17.
That's interesting.
Yeah.
Yeah. I mean, at a stretch, maybe abatage is 14, but I'm not even
Yeah.
sure.
Yeah. True. Yeah. Arbatash. Yeah.
There you go. That's next to 17 on the roulette table.
I thought it was mainly just Chinese people that played roulette. I didn't realise they were.
In Chinatown, it is, and in casinos all across the country, yeah. But in West London, it's the Arabs that keep the casinos alive. The people coming from Saudi Arabia, Kuwait.
Imagine it more than keeps them alive.
Yeah, it does very well for those casinos.
I don't know why people who playing casinos, they must know that it's rigged against them. Are they just showing off that they can afford to lose this money, or like what's the?
Oh no, it's very addictive. I've seen many a person ruin their life in there. So it's just very addictive. You get a buzz if you win on roulette. Plus, people genuinely think they can beat it, like games like roulette and baccarat, blackjack, and obviously you can't, not unless you're cheating.
Well, the best you could do with roulette is reduce the house margin to like 1% or something. But even then,
Yeah, you can knock the house edge down to roughly 1.4%. That's if you play even chances, red black. If you're picking numbers, it's 2.7%. I mean,
which means sooner or later you're losing all your money.
Yeah, that's it. I mean, you can knock blackjack in your favor if they're dealing out of a shoe, like a manual shoe, and you're counting. But now in the UK, it's almost all machines, and they're going to shuffle the cards almost continuously, make it near impossible.
All right. Take care, guys.
Yeah, no salt. Check later. Might be some. It's usually quite salty in these parts.
Yeah. I'll be back then.
As salty as the Dead Sea. Notice how he was so afraid to tell me he was a Glober.
Yeah, he came to watch the smoke or listen to the smoke. He didn't want the smoke.
Right. Oh well. Maybe we'll catch another filthy Glober. You're a croupier.
I have been. I'm not right now, but I have been for a while. Croupier, it's kind of a fancy word for it. I mean, now they might just dealer or whatever. But
if you tell people you're a dealer, they assume drugs, right? So.
Well, yeah.
But then the problem with croupier is that it's a French word, and that's not acceptable either.
Yeah, It's true. Well, I guess so is roulette. And that's what you do. So I don't know.
Oh, yeah.
The devil's game. Do you know? Do you know what all the numbers on a roulette table add up?
666.
666. There you go.
Yeah, I heard that somewhere before.
It was invented by a French monk, apparently.
Bit like the heliocentric model.
It is. It is actually. Yeah. Good comparison.
Actually, I think the heliocentric model was a Polish priest, but sounded French.
Oh, yeah, it's the Big Bang. That's like a French monk in it, or French priest, or Italian priest. Something.
I don't know. All that stuff doesn't really interest me that much because it's like, I know people like to rub Glober's noses in it by saying, yeah, you follow a religion too. So, and it's true that they do. But just because a guy said a thing, like, that doesn't really prove that it's legit or that it's not legit to me,
That is true. Yeah. What's that? The fallacy or something like that. Just because they use the fallacy doesn't mean it's not true.
Yeah. Something like that. Although there is, of course, the fallacy.
Wait, I can't even get my head around that. So, yeah.
Right, I'll be back in about 20 minutes.
Bye.
All right.
Hello? Hello, guys? Hello?
Hello.
Yo, whoa, 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 whoa. Coding! Oh, wait, you're a flat earther. Oh, shit.
Hell yeah. Hell yeah.
Do you think that, like, you have, like, the cognitive capacity, like, of a 14-year-old child? Would you say that?
I would say I have 2 degrees and you don't have any, is what I would say.
No, I'm asking you, do you think that your cognitive faculties are gonna be, like, those of a level that, like, 14-year-old would be labeled as?
Well, I have 2 degrees, so you tell me.
Degrees in what? Degrees in what? Stupidity?
Well, no, one's in music production and one's in finance.
Finance, right? But those are not like gonna be um degrees that are actually gonna like help in
Help
patterns.
with patterns.
Yeah,
They're both, they're
patterns.
both with what?
Patterns equals intelligence. The more you can find out patterns in stuff, the more you're intelligent you are.
Both of those degrees heavily rely on pattern recognition. What are you
No,
talking about?
no, they don't. No, they don't.
They
They
do.
maybe rely. A small part of them relies on on pattern searching, but that's not gonna be like the whole. That's not gonna be the rudimentary, like fundamental aspect of that degree.
I think you're reaching quite a lot here.
Yeah, so what I'm asking you is that why do you think what I'm gonna like um uh, what I'm gonna be asking you is whether or not you think that NASA is lying.
Yeah, I think that's full of shit.
NASA's full of shit.
Yeah.
What? Why do they lie? Why do they lie?
Well, because they earn a fat paycheck to do so.
Yeah. So why are they paid to do so?
Well, because the government writes them a check to do so.
Yeah. So why do they do it?
Because they get paid to do it.
No. This is circular. I'm asking you, why would the government want
Yeah,
to
I know
lie?
it's circular. Give me a sec. I need to go and do something.
Why would
It's
the
just,
government want to lie about the flat Earth? That's what I'm asking you.
well, that's a different question. Back in a sec.
What? What? Look, if you're not gonna like talk, then
Yeah, why does the government want to lie? I don't know. Fuck do I know?
oh, have you reached the conclusion that the Earth is flat? Like, so you're saying that the NASA lies that it's round, right? But is it a
Yeah, I
true
think,
dichotomy? Yeah, but the thing is, why did you choose flat? Why can't it just be, for example, heart shaped? Because you're saying that okay, NASA is lying that it's round,
I'll
but
be honest.
now you're
Stuff to
concluding that
do,
it's
and
now you're
I'll be honest.
concluding.
I've got other stuff to do, and I can already tell this is not going to be a productive conversation. So maybe someone else can take out.
Wait, but isn't this like 24/7? Yeah, kill yourself, bitch. Fat earther. Hope you die. Just as up.
Okay. Yep.
Yep.
Where them globies at? Hello, anybody here? I'm Batman.
Hello, hello, hello.
What up?
Is there anybody out there?
Yeah, man.
Oh, damn, dude. Dude, I gotta fix my shit. Hold on. I gotta put on speaker. All right, heard yeah, man. I put on speaker now. What's going on?
Nada.
Can you say like just 3 words? Because I'm trying to figure out if my phone is the output is in the head or like the bottom.
What doing, homie?
There we go. Thank you. All right, I gotta turn on my phone. Hold on. I turn the volume all the way. I'm all the way up. Hello, does anybody here believe in flat Earth? I am alone.
Yeah, it's not a belief, right? It's that you know it. You know it to be
Crit,
flat.
no. Crit, no. Crit, I'm just letting you know. I love the messages you send me every day.
Well, thank you. I know some people really appreciate it. Other people are like, "Stop sending me crap."
And it's honestly it's pretty original because I've been here for like 4 years, never seen some shit like that. So I respect the originality. God, I feel good, dude. I fucking just took a shower, washed my balls, put my new shoes, new socks, fresh laundry, deodorant. Trying to talk to some ladies right now. Feel good. You never see any like ladies like come in and try to talk about flat Earth.
Yeah, we have a ladies' night.
Oh, when is
It's been on
when's that?
hiatus for a little while.
What day is it?
It was normally Friday.
Oh yeah. Tomorrow's gonna be a good. I guess I gotta wash my balls tomorrow. Good deal. Yeah, because I like talking to dudes. I mean, I don't like talking to dudes. It's like, dang, dude. Sometimes I want to talk to some ladies.
You'll probably pick up again after the holidays.
Yeah, dude. I must be ugly as fuck, dude. Because like, I mean, maybe I'm just too nice, but like, I'm like everybody's like, yeah, dude. This girl in the server, she sent me a picture of her boob. And this other guy's like, yeah, this chick like sends me pictures of her boobs. I'm like, damn, dude. Am I just like too nice or like ugly? Like, damn, I've never got no damn boob pic. Crit, has a girl ever sent you a picture?
What does this have to do with the ground?
That is correct. Well, I mean, we talk about flat Earth 24/7. Can we get like 1 minute of ladies talk? We stop
I'm just
we stop
fucking.
talking about ladies, then like the next thing you know, everybody's trans and fucking You gotta remember the roots. The only reason I fucking talk about flat Earth is because I don't got no damn fucking lady. If I had a lady, I would never talk about conspiracies, fucking flat Earth. I wouldn't give a fuck. That's why
You
I
gotta
think this.
find the person that's also into that too. See, it's like
Yeah.
that where you have like a commonality. I got this really powerful meme where it's like like speed dating, right? And it's like like they ask it, hey, what is government? And then like the woman says violence, and then right away they start making out right there on the table. Find someone with a commonality. If you're gonna find some sort of normie, they're gonna still think it's okay to call the police for every little thing that upsets them. You're gonna have to find like an independent, free-thinking woman who's ready to break social norms.
For that, I really think I probably got to go to the library.
Yeah, I mean, you're not gonna find them at the bar, all doped up and sedated on alcohol and calories and happy hour fried pickles and whatnot. You're gonna have to find something like at the go to the gym. Go to the library. You're not gonna find like someone who's gonna be like, what time's the Kardashians on today? It's not just, and then once you find the right type of people, you can start networking, and who is like who's available, who's looking for a husband or a wife. And there's been a lot of over the years in flat Earth, people who have met each other through this topic and have gotten married.
I need to make a Tinder, but like my problem with Tinder is like when I would do that shit, I would never really have like connections like that. I never really had hobbies, and like I was like, all right, I'm not getting. I fucking bought premium. I'm fucking. Let me see what the dudes are doing. Like, what are they doing compared to what I'm doing? And like what I was doing is like a mirror pick like far away, me with like my dog, and then like their pics, other dudes' pictures are like them on a boat, them with like 50 friends, them at a party, them like just doing so I'm like, okay, I gotta do like crazy shit, like not crazy shit, but like I gotta like diversify my portfolio.
Well, it's also the pool of people you're looking at too. I've heard people for e-dating and stuff to use e-harmony because like you match and then you write essays to each other. There's like a progress, a series of steps you have to take before you meet in real life to keep showing that the people are invested in the relationship. Where if just all it takes is a swipe right or left, there isn't much there to begin with.
Yeah, dude. To be honest, when I was 16, I was like, I kind of felt embarrassed. Like, man, I'm fucking using Tinder. I'm using online to fucking meet women. This is embarrassing. But like when I was like 10, I went to the mall. Like I went there like last week, but I went to the mall when I was like 10, 16 years ago. Dude, it was so packed you couldn't even walk. Dude, it was packed. And I went to the same mall. I'm like, all right, I'm 26. I dress good. I smell good. I can talk to women. Let me get my game going. Dude, there's like one guy in the whole mall. And I'm like, damn, dude. So I think it's like the only option is fucking online, dude. At least where I'm at.
Yeah, I mean, okay, or it's also too like peer groups. Who do you know? Like, do you have a church that you go to? Is there like like a card club you're involved with? Is there a gym? Do you go to the gym?
Three main places what I got to do, because what I notice is that when I have a routine. Like I do the same thing. When I went to the gas station at a certain time, eventually I started seeing women in there, but I'm like, dude, I'm at the gas station. I don't know what the fuck to talk about. But I'm like, okay, what I got to do is I got to go to church at the same time, library at the same time, and the park at the same time. And eventually, because women are like tigers, dude. They're like watching you from the bushes.
Yeah, if you have a dog, yeah, you go to the park, and a lot of people meet that way too through their dogs. It's a good icebreaker too, because dogs want to walk up and be very social with each other. And then while the dogs are doing their thing, the people talk.
And then when the dogs start humping, it's like that puts it in her mind, like, oh shit, I want some of that. No, now they say women think about sex more than men. Like they just hide it. They are way more horny than men. Like I went to the office to play bingo 30 minutes ago, and I got sweatpants on. And you could see like the full outline of my junk. And when I went up to claim my prize because I won, dude, this chick was looking right at my shit for like 5 seconds, right at it, and then she started laughing. Not like laughing at it, but like she was like pissed. But then she was like in a good mood after. I was like, hey, my pecker put her in a good mood. Yeah, I like sweatpants because you can show off the thang without showing off the thang.
Camel toe, snuggling or peacocking.
I make sure when I go somewhere, it's weird because like the hospital has like a lot of fucking fine women, and like I made sure when like I was walking by the front desk where there's like this girl, and when this other girl walks out the elevator, I know she was looking at me, but I made sure she sees me looking at the ass. Because I want her to be like, why is he looking at her ass? All right, I got to work on my ass. And then it exponentially grows. Eventually, every woman will have an incredibly nice ass.
This is gonna
All right, let's get back to flat Earth. Well, if you look at the astronomical thermodynamic equation of Thwaites Glacier, you can obviously see that the stars in the universe align. It's like, damn, dude, why are we making it so complicated? All I gotta do is go, okay, when I look at train tracks from a distance, they look like they're converging, but they're not. When I look at the lights at the end of a hallway, they look like they're getting closer. Okay? And when I look at the horizon, it looks like everything disappears over the horizon. So maybe my eyes are not showing me what's actually going on. Eventually, everybody will be a flat earther. I'm telling you, dude. In like 50 years, we're all going to be flat earthers. We're just the originators. We're the original fucking people. Like they're gonna be like, Grandpa, how did you feel
I
when
like
like
to remind people
say that again?
the United Nations. I like to remind people the United Nations has flat Earth map, so not all flat Earthers good, and there's gonna be a lot of weird crap happening in the future.
Yeah, there's gonna be a lot of like right now, like the distractions are like school shooters, Ukraine, Russia, Taiwan, China, Corona, transgender. But like in the future, when like more and more people start catching on, because that's what they don't want. Like if you're the controller of the zoo, it's like okay, if the giraffe figures out he's in a zoo, the worst he can do is like lay down and cry. But it's like if you get 7 billion people that realize it with money and resources to like do something about it, something something we're gonna break out of the fucking zoo. So we gotta do everything we can to not break out of the zoo. Hey, I gotta go. Long story short, I got a medical bed being delivered. I'll catch you on like 30 minutes. Peace out. Love. God is real.
Stay blessed, man. Watch out for zombies.
Hello? Hello?
Hi, I'm Manufactotum.
So, hello? How's it going?
Yeah.
The Earth is shaped like a donut.
Old joke. Try better.
No, I'm not joking.
Where's Manufactotum? Fatfish, I think you need the minor role, bro.
Huh?
I think you need the minor role.
I'm not a miner.
Yeah, look, I heard that laugh. It had voice breaks in it. You know,
Yeah,
can't hide it from me.
late puberty. Boom.
Uh-huh.
Yeah.
if I'm hated, yo, nigger, 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 nigger. Nigger, 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 nigger. Nigger, 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 nigger.
You account for, see where it says Kent Island North Basin Triangle 2. From Marionette and Taylor, you can see the angles.
Friend, I don't give a crap. What does it mean other than you're going to affirm the consequent that the Earth must be curving?
I'm trying to explain to you what it means, but you interrupt me to tell me that you're not interested. I don't understand what you want me to do.
No, I'm not in. Okay, so you've got numbers. Great, you got numbers. Now what? You can tell me all about the numbers and the corrections. You can tell me about all that stuff. But all you have is numbers, and they're not associated with Earth curve, which you mentioned earlier, right? These are just trying to figure out where we're mapping stuff, right?
Yes. Yeah.
So at no point do we need to bring this idea of being on a ball. We just have numbers.
You're right. So, the whole point of the survey was nothing to do with Earth curvature. It had to take Earth. It had to use these angles though to map out the United States, and they did a measurement at the end, and they were off by 3 centimeters, off of the predicted value off of previous models like Bessel and Clark from this measurement.
Yeah, terrific. Doesn't have anything to do with Earth curve.
Okay, so now what I'm going to need you to do, if you want to keep arguing that the Earth is flat, is you're going to need to
argue that the Earth is flat. I didn't make that claim. What are you talking about?
If you're going to argue that the Earth is not a sphere, then you have to come up with some explanation to how these angles add up to more than 180 degrees every time.
But why do I?
Because then I have, this is evidence that I have that the Earth is a globe.
No, you don't have any evidence. You just have numbers.
And no, they don't add up to more than 180 degrees every time.
Bob, I talked about this so many times.
There are cases where it's less.
Okay,
you only need one to have where it's less.
I'll talk about it for a fifth time now.
Who's cherry picking now?
I'll talk about it for a fifth time. The picture that Amish professor posted at 12:27. What you're talking about is you're talking about the left-hand side, right? With the boxes that say 179.59, right? That's what you're talking about. These angles, if you look at Kent Island North Base, I can talk about this all day. If you look at Kent Island North Base, right? And if you look at it from Marriott and Taylor, you say, oh, Kent Island North Base, Marriott and Taylor are 38 degrees, 30 arc minutes, and 31.55 arc seconds away. But if you look at similarly, you can see that Kent Island North Base and Taylor are that angle from Marriott, but you can look at Kent Island North Base from other places, and these slightly disagree because measurements are not perfect. So Kent Island, we're in disagreement about where Kent Island North Base is. So what do? What's your solution, Plum Bob, to us being in disagreement about where Kent Island North Base is? We have to take multiple measurements, and we have to say, well, based on all these measurements, this is the most reasonable place to say where Kent Island North Base is. So that is what the middle column is. Okay? Now I've talked about it for a fifth time. And
I don't know why you're diverting back to this. I don't know why you're doing this. I'm asking you, it's a very simple question. It's a very simple question. Whether it's 180 plus or 180 minus, you have numbers. The conclusion that you're drawing has a presupposition in it, does it not?
The conclusion, what I'm saying is, if you're on a flat plane and you take 47 different triangles, it is very strong evidence against that surface that you took those triangles on being flat.
Says you. I mean, there's a lot of different reasons that could be.
Okay, what is one reason?
I think we talked about this earlier, didn't we? I mean, if we have error in basically all these measurements, then how do we account for those errors? What do we blame those errors on?
Well, one thing that you could do is you could say, well, we took these measurements with different people, different places, with different theodolites, and we all got the same error. So maybe it's not an error.
I mean, okay, so you could eliminate a couple of things. That's not what I was talking about, but what else could it be? Let's brainstorm, you and me. Let's talk about how we might have an error instead of just affirming the consequent. And then how would we prove it? We'd have to kind of prove it and test our theory, right? Because at this point, you're not even at a theory yet. We just have numbers that don't add up to 180, right?
Okay. So
not on the surface, above the surface, by the way, right? We're going to clarify. These are above the surface, not on the surface, right? I just want to get that clear.
These are above the surface. These are line of sight
Okay.
measurements.
Yep.
I
Yep.
already talked about
Perfect.
that. Though. I talked about that for
Oh, great.
10 minutes. So
I know, and you're talking about vertical planes, but then you're talking about azimuth, which is horizontal plane. So
yes, because I'm talking about the
keep
angles.
mixing stuff
I'm talking
up.
about the angles.
So why are
between
we
the
mixing
vertical
stuff up?
I'm talking about the angles between the vertical
Uh-huh.
planes. Okay, so if I
So
were
we're
to
not
design,
measuring a triangle across a plane.
we are. We are. I'm sorry. Okay, so
Okay.
sorry. I don't normally get this
Mm.
heated, but I've never had to repeat myself more times on the server than today.
Me either, man. I can't believe I have to do this either, but I'm being patient.
Yeah. Sorry.
You can be
I'll calm
patient,
down.
right?
I'm sorry. Yeah.
Okay.
Sorry. So. Okay, if I were to design an
So
experiment,
we have numbers, and we're not thinking about anything else. I don't want to talk anymore about hypotheticals with you, okay? All of your hypotheticals suck, quite frankly. And your hypotheticals always beg the question of a ball. So we're not going to do that anymore. So we have numbers. What are we doing with these numbers?
okay, if I were to design an experiment, okay.
I don't want to talk about if. We have numbers. Now what?
What do we do with them, or what do the people that took the survey do with them?
Well, I mean, they went ahead and affirmed the consequent. You've decided to affirm the consequent with them?
They
so what are we going to do with these numbers that we got? Okay. Well, then why are you doing it?
Because their purpose was not to say anything about the shape of the Earth.
Okay, then why are we bringing it up?
Because this is really good evidence that you can ignore refraction, you can ignore all these other variables because they're azimuthal measurements. I think it's very compelling evidence.
Azimuthal measurements across a horizontal plane, right? Above the surface, so that has nothing to do with the surface. And then you're going to go ahead and affirm the consequent that this makes the Earth a ball because you have numbers.
Hold on. Kiwi Buzz posted at 12:25 my picture next to a picture of two lines on Australia. And the thing is, the line on the top and the great circle between those 2 points are not in the same plane that this camera is. So these are falsely equivalent. But
great. So we can ignore the chat and we can go back to the question that I just asked you. We're not going to get distracted, right? We're going to focus on what I'm talking to you about. You have numbers and you have affirmed the consequent of the ball, and I want to know why.
Because it is so much simpler to look at these numbers and say, wow, the explanation must be that the ground is curved, than to say some ad hoc thing that still concludes that the Earth is flat. Because you have to come up with.
Excuse me, no one said anything about the Earth being flat. Why do you keep wanting to make this about the Earth being flat? Why are you trying to straw man me? What is the deal, bro?
You're saying the Earth's not curved, right?
I'm saying that I'm going with you on this one, man. You have numbers, but
your claim is
you and I are looking at the same data. No, I'm not making any claims about this particular measurement. Yeah, your claim is that the Earth is a ball because of these numbers, and I just want to know how you got from A to B.
Okay, so first of all, what are the alternatives if the Earth is not a ball? What are the alternatives?
Why are we even talking about the Earth being a ball or not? All we have is numbers.
We're trying to make a hypothesis before we can determine what these numbers mean.
This is not science, my friend.
Why is this not science? I don't understand.
What is the naturally observed or occurring phenomena in this particular example, this 900-page document? What's the naturally occurring phenomena?
Angular excess between these observation angles.
Angular excess is not a naturally occurring phenomena.
Yes, it is.
Okay. So I can see excess in nature. I can go out and look at this with my eyeballs.
Yes.
We're testing something, cause and effect. Okay.
Yes.
I've never seen it in my entire life.
You get further away, and the excess becomes bigger. That's cause and effect.
No, it's not an event. It's not an event. It's not something occurring and happening.
You don't. Nothing has to.
What you have. What you have is men with instruments, right, out taking what they call measurements, and then they get numbers that deviate from what they would expect. Okay, these are numbers and measurements, right? So already we have a problem in this entire scenario, and it's not a naturally occurring phenomena, by the way. All right? So this is not science. This is math. So there's no hypotheses in this math that you're talking about today.
Okay.
Okay. So you're going to hypothesize on math, which is already, like a big time category error. Why?
No. I'm hypothesizing.
No.
I'm making an experiment that uses this data that's already been taken for us, so we don't have to go out and use more data.
Okay. All right. So you're making an observation. You come up with this excess. I'll go with you for a little bit on this. So the phenomena is excess in measurements between lines of sight. That is the observation, correct?
Yes.
Okay.
Yes.
So
And
your
if you look-
hypothesis is, and your hypothesis is.
Okay, we're not done looking at the data though. If you look at the data, the bigger the triangle, the more excess there is. It's not just.
Terrific, fantastic.
So
the hypothesis is.
So
no, just one. We have to test one at a time. You don't make multiple hypotheses in science, even though this is not science. You test one at a time. So give me your hypothesis. What is the presumed cause of this measurement problem that we have?
Our first hypothesis is that there's an error in this measurement.
Okay, there's an error. How would you determine whether or not there's an error? What could we wiggle to see if there's an error?
You take more measurements.
Let's wiggle people first. Let's take different people. Different people, different equipment, different locations, different altitudes, right? We can keep doing this, right?
Yep.
Right? Okay.
But
so what do we come up with?
We come up.
Did you do this?
We come up with the same spherical excess. No, but this.
Did you do this? No. Don't you dare. Hey, hold on a second. Don't you dare do that. Don't throw spherical in there. Absolutely not. Dude, come on. You be above board in this discussion, all right?
Sorry,
excess. We have excess.
We still get excess. Okay. We
have excess. Now they did this. They did this, right? How many different surveyors? How many different pieces of equipment? How many different locations? How many different altitudes? How many different days of weather? I want you to show all that so we can eliminate some of this stuff.
And how about how many observations from the same point to point?
Yeah, different days, different conditions. Show me all that.
Okay. Here's this. I'll just post screenshots here. If we're talking about single points, one second. I will post this.
Did he say measuring 3 points gives you a spherical triangle? I'm just catching up.
Okay. So
yeah, it's the same old song and dance.
I don't want to talk about this again. I've already gone over mathematically how you can do this.
Bro, you've only just talked about how you have affirmed a bias, and so have these people apparently, and they wrote spherical excess because they have numbers that deviate. And that's all you've done. That's what you've proved today, is that you like to affirm the consequent. And that's fine. Like I told you, you can have your ball. No one's going to come take it away from you. Enjoy your imagination. Right, it's cool.
Sorry, I did make a mistake here. I posted zenith measurements. Those are not. That's not what we're talking about. But you can see what they've done here. They took measurements on different days, different hours of all these different places.
Mm-hmm. Okay. Yep. Cool. And I got different results.
Well, these are zenith measurements, so there's gonna be a refraction that we have to take into account for zenith measurements.
Oh, okay. So those are no good. So you can just throw those out. We don't need those.
Yeah, but
that's not what we're talking about here today, right?
You're right.
Okay.
You're right. I posted this before I read zenith distances. But you can see what they've done is they have measured for all these points. They've measured almost every hour for like a full week.
Mm-hmm. Great. And they got different results?
For zenith, yeah.
Okay. So there is variations depending on the hour of the day even. Wow.
For zenith, yes.
Cool. Look, great. For zenith, which is not what we're talking about, right?
Look, are you trying? Sorry. Okay. Yeah, I'll try.
Even though we're not doing the scientific method with math, right? So even though we're not actually doing natural science in this scenario, we have variations, but according to, I mean, there's still plenty of observation, or plenty of reasons why these observations could be different. But you're going to just stick to it has to be a ball, and that's okay.
No, so our first hypothesis was that there's error here, right? and we're talking about
That's just one hypothesis. So we do have error according to the multiple measurements that we take. So we've confirmed that there can be error just according to the different time of day, probably different weather conditions. So already we have error. So we've affirmed error. What's another thing that we can affirm?
we've talked about differences in zenith measurements here.
Okay, but there's differences. Cool, right?
Yes, there's differences in zenith.
Reason for error. There's one reason for error. So we've affirmed that there can be error even though you take multiple measurements. Great.
Zenith and azimuth are independent.
Great. So we're not even going to talk about the zenith anymore. We're going to throw that out.
Yes.
So why don't you bring up the azimuth measurements that they did a ton of, different pieces of equipment, different guys, different days of weather. I want to see it all. We shouldn't just go ahead and assume ball, right?
Yeah, I mean, you don't have to assume ball if you don't want to. That's fine.
Okay, well then let's not assume ball. Let's just go ahead and go through all the other possibilities that could be at play here, which I think is going to be more than just a couple. We could get real creative and think about, I wonder if moon phase has anything to do with this. You could test that too, probably, couldn't you?
Are you serious? Moon phase?
Why not? Well, I mean, dude, according to your model, the moon makes the entire ocean move. So there could be an effect from the moon, don't you think?
Yeah, ocular effect from the moon. I guess like if you're looking at like the sky, there's a limiting visual magnitude decrease on what you can see.
In your model, the moon and gravity does all kinds of stuff. What if there's like gravitational waves that change the measurements and stuff? We'd have to go ahead and test gravity
If we're talking about this, we have to make different experiments to test for this.
I know, we should do all of that. We shouldn't just go ahead and assume a ball, right?
This has been done.
Has it? Show me. Show me in this particular scenario where they went ahead and tested the gravity to see if it affected their, measurements and stuff.
Okay, what I'm saying here is they didn't test for gravitational waves from transcontinental triangulation of the American arc of the parallel in 1914 or whenever this was done, 1904.
Okay.
What they did later on is they tested gravitate. They were like they didn't even think gravitational waves existed until 1915, 1916 or so.
Yeah, they're still not sure because it's just an imagination, right? Gravity's just imaginary.
Oh, we could talk about gravity.
Yeah, I mean, since you just want to assume ball, we can go to gravity next if you like. The bending and warping of conceptual mediums.
The deflection of the vertical.
Pushing you down.
Yeah. So yes. So something pushes us down, right?
No.
Nothing pushes you down.
There's no exclusive downward vector for all matter unless you can prove that, because I see gas doing all kinds of crazy stuff.
Yeah, so you can have multiple forces acting on something. So you can
multiple forces, so not just one now.
If I throw a ball upwards, it doesn't cease to accelerate downward.
Oh my gosh. So vector doesn't even, we can't even measure vector at this point. So you're saying if a ball goes up, it's still going down?
No, it's accelerating down.
It's accelerating down as it's going up.
Yes. Have you taken calculus before?
What does calculus have to do with physics in this scenario?
Acceleration is the derivative of velocity.
Okay, great. So the ball is accelerating downward as it's going up.
Yes. Which means it's going up. It's okay. T-Dub, you laughing at this is actually really funny. So if something's going up, it can still accelerate down, and if it does that, it will go up slower over time.
Bro, is it not just decreasing in velocity? That doesn't mean it's accelerating downward.
That is exactly
okay. So it's not accelerating downward.
No, I cannot believe I'm arguing about this. This is so funny. Okay.
I can't Me either. About it either. It sounds fucking ridiculous.
Wait.
When I let go of a beach ball from underwater, if I take it to the bottom of the pool and let it go, and it goes up, is it accelerating downwards?
It's accelerating upwards, but the water around it is going down, right?
Is the beach ball accelerating downwards?
The beach ball is going up, but the water above the beach ball is going down.
What about a helium balloon when you let go of that and it goes up in the air? Is it accelerating downwards?
it's going up, but the air around it is going down.
Is it accelerating downwards?
Yes, but that's not the full picture.
Is?
cow.
Oh my god.
Is a rock laying on the ground accelerating downwards?
Okay, if we want to talk about general relativity, then yes. Actually, it's accelerating.
So when what about when it's coming back down? Is it accelerating upwards?
No.
Why not?
Because everything always, if we're talking about gravity as a force, then
Oh, there it is. There it is.
Okay, so we can
More hypotheticals.
if we're talking about a downward force, right? Then us standing on the ground is an inertial reference frame. Okay, that means everything.
That would be
that has-
non-inertial, but okay.
I'm saying if we're talking about a force that's pulling things down, then we would have to be on an inertial reference frame. Because we're not
Well, I guess
accelerating.
Coriolis is out of the windows then, because then we're supposed to be a non-inertial reference frame.
Okay, we can complicate the model as much as we want, but sorry. This is I have an engineering background, so we talk about things as simple as possible to convey the idea. Okay, we can make the model more complicated if you want, but right now,
why if you have an engineering background, you don't tell your peers, look, I did all this work, but we're going to just simplify it down to if you roll a pencil, it's going to go bumpity bumpity bump. And then because you didn't figure out why it does all that, you're just going to say if you roll a pencil, it goes bumpity bumpity bump. There's my results. Let's move on with the project. That's not how it works.
Look, okay. First of all, I'm not the one saying that things can't accelerate in a direction opposite to their velocity. So
you're not?
No, I'm saying that things absolutely can accelerate
you have
in
a
directions
bias.
opposite to their velocity.
Well, why are you saying that though?
Okay, so
Because that's what you were told.
If a rock is rolling towards you and you want to slow the rock
Mhm.
down, you're gonna push it, right?
Mhm.
And you're gonna slow it down, right? So this change in velocity is gonna be negative, right?
Yeah, is that an acceleration?
Yes, acceleration is change in velocity.
There goes Earth spin.
We don't talk about Earth spin.
No. I'm backing that up into the corner for later. You already eliminated that just now.
Well, how did I eliminate that? Can you enlighten me?
Yeah, because circular motion is a constant change in velocity, and we don't feel that velocity, which we're supposed to be feeling, so we're not spinning.
That's exactly what I started with when I entered in here. The measurement of that.
There is no measurement of that.
Things weigh less on the equator than they do on the North Pole.
And
that's
you've done
exactly
this.
measurement. That's exactly measurement of. There's so many people.
Hold on. You've checked this. You've checked this.
Yes, I can do the experiment if you want.
You went to the North Pole. You went to the North Pole.
No, I'm not saying that you have to go to the North Pole and the equator. I'm saying that as you get closer to the equator, things weigh less.
So I should be able to go to see somebody down in Columbus, Ohio, from Cleveland, Ohio, and I'm going to lose weight just by driving a car. So
yes,
that's a good
very small amount. Yes.
Yeah. Okay.
Is that your rebuttal?
Right, but once again, are you going to affirm the consequent in this scenario?
No. What was said to me was that we should feel if the Earth is rotating, and I say, yeah, there is a centripetal acceleration that's pointing away from the Earth, right? The Earth should be falling away from us, right?
Why does he say right? Like we're supposed to agree with
Doesn't
him?
need to be spinning. Yeah, no, we're not agreeing with you, bro. Here's the thing. You're affirming the consequent in each of these scenarios, right? Like you have not once not affirmed the consequent. You say things weigh less in a certain place because, but you actually haven't told us, showed us that the thing that you are saying the because about exists in the first place. You're just making observations, and then through your bias, you're affirming a consequent. I want you to show me the motion of the Earth, and do it now.
Okay, 1 second. I'm gonna pull up measurements. I can show you
Not
measurements
weighing
from a bunch of
things
people.
either. Not weighing things either.
What do you mean? I'm talking about the weight of things. Why wouldn't you weigh things to find out the weight of things?
That doesn't have anything to do with motion, unless you're affirming the consequent. Unless you're going to affirm the consequent, no, it doesn't.
No. So here's what happened. Radwin
Now
told
the Earth
me.
is a non-inertial reference frame.
Radwin told me that if the Earth is spinning, we should feel it, right?
Yeah.
So what I'm saying is you
And
can
what
measure
inertial
the
plane
difference.
should be measuring it in? What inertial plane should we be measuring?
Okay.
Kilograms, I guess.
No, that's incorrect. You measure in weight. So this would be newtons or pounds.
This is affirming the consequent.
No. Because Radwin said that, oh, the Earth is not a globe because we can't feel it spinning. And I said, yes, we can measure it spinning. Now I can't say that without affirming the consequent. I'm just saying we can measure the differences. We can measure the differences between weight of things depending on what latitude they are.
Sorry, you went ahead and put words in Radwin's mouth. He didn't say the Earth is not a globe because we can't feel the Earth spinning. He didn't say that.
Yeah, regarding
You said that.
what you just said, there's actually a precision scale company that did this. They took a garden gnome and they brought it around the world to different latitudes, weighed it. Problem was the prediction didn't match what actually happened. I'll post it for you if you want.
Yeah, I would like to see that. Because I have.
Anyways, you're going to affirm the consequent because things weigh less in certain places. You're going to affirm that the Earth is spinning. Why don't you actually just show that the Earth is spinning and what inertial plane we're going to measure?
Also, when you move a scale, you're supposed to calibrate it, not hit 0 and then move on. You're supposed to do it properly.
Yeah, no. If you calibrate it, then you're gonna get the same weight. But if you don't calibrate it, then your scale is still gonna think that you're.
That's the reason why you're supposed to calibrate it.
If you calibrate it, so
Dude,
say
we have
100 kilograms.
We have about 1,000 scales at work. We have a full-time company that just calibrates scales all day long. That's all they do is just calibrate scales because people move them around. So they got to come and calibrate them.
Okay. Cool. Thanks for posting the gnome experiment. I appreciate that. So okay. When you take a scale, right? And we have a 100 kilogram test mass, okay? And you put that on the scale. What the scale is doing is it's measuring how hard that mass is pressing on the scale, right? Which is due to the acceleration downwards that this mass is feeling, right? If you drop the mass, it's going to accelerate downward, right? So that mass, that scale is feeling the acceleration downward due to that mass, or of that mass, right? And it's gonna do math
If you
inside
say
the
so.
scale. Okay, okay. How do scales work, T-Dub?
I'm just going along with you at the moment. If you say so. All right. But continue.
Okay. So the scale will do math and tell you how many kilograms this thing is. But the way that it tells you how many kilograms this thing is it divides out the acceleration. Okay? It takes a number and then it divides it by 9.81 and then it gives you the answer in kilograms.
Okay. So if we take this same scale and this same, let's say a rock, right?
Yes.
And we take them down to the bottom of a pool, is it going to give me the same reading?
No, because there's buoyancy involved. It's probably going to give you a higher. It's going to give you a lower reading. All right, I'm not going to watch the gnome experiment now because it's an hour-long video, so I'll watch it later.
And this means Earth is spinning. Why?
Because if you take the scale at one latitude and you calibrate it for that latitude, right, and you bring it to a different latitude, your results are going to be off.
And this means Earth is spinning. Why?
No, it just means that there's some other acceleration that has to be accounted for. That the globe model has an explanation for this acceleration, but the flat Earth model, as far as I've ever seen, does not.
So
we're not looking for explanations.
I thought that's what you guys do, right? You look for explanations for things?
No, we're looking for proof.
Okay. So
everybody has explanations, son.
Yeah. You weren't supposed to make up a story. You were supposed to lead us through the logical, to the logical conclusion. that
Don't let
because
your
of this, then
don't
that.
let your engineering friends hear this either.
Okay.
Well, he's conflating a bunch of things together. I mean, what Radwin said is you don't feel the Earth spinning, accelerating. He's gone and tied this weight thing to that and said, yeah, you are feeling it. Like, I mean, that's obviously not what he was getting at.
Yeah, no, that is what I'm saying is that you can weigh things at different latitudes.
Yeah, you're not feeling the world spinning around. Sorry, nice try.
Okay.
And as long as
So
you don't calibrate it, you'll get wrong answers. That's good. That's why you don't just send scales in the mail and say, "Here you go." Don't do anything but put things on it now.
So what would you expect to feel if we were on a globe spinning as fast as the globe spins? What would you expect to feel?
I would probably be throwing up all the time.
Okay. So we're talking about circular motion, right? So
Yeah, that's
when you
what
talk
makes me throw up. Circular motion makes me throw up.
when we talk about circular motion, we measure things in angular velocity, right?
Yeah.
So the angular velocity of the Earth is 15 degrees every hour. So if you get into a car and you turn at 15 degrees every hour, it's going to feel like you're basically going in a straight line.
Prove it.
It's still going at apparently 1,000 miles an hour at the equator. Angular velocity has nothing to do with it. There's still an actual speed.
Circular motion is not measured in linear velocity. Linear velocity
I don't
is
care. I don't care how if you're going to measure it that way. That's fine, but there's still an actual speed to your fairy tale.
speed is all relative. It's speed is there's no absolute speed.
Well, I mean, when he said that it's just going to feel like going in a straight line, he told you that you're not going to feel any of the acceleration, but he just spent 10 minutes before that telling you feel it because the weight changes.
I said I didn't say that you feel it because of the linear motion. I said you feel it because of the
No, when you
centrifugal
said it's going to
acceleration.
feel like a straight line, what you said, really, without saying it, is you're not going to feel any acceleration.
Yeah, you in your everyday life, the acceleration is not big enough for you to notice it in your everyday life.
Right. Yeah, so scratch
Yes.
that 10 minutes you spent before that trying to make a case for how you do feel it.
No, I said you can measure it with precise scales.
Yeah, that was stupid, though, because you were responding to Radwin saying that you can't feel it. And this was, well, yeah, you can feel it because the weight changes, and you're trying to tie that into somehow feeling it. Now you tell us it just feels like going in a straight line, which is not acceleration.
You're right. You're right. I conflated feeling it with measuring it. That's my mistake. You
Sure
don't.
did.
Yep, that's my bad. You can measure it, but you cannot feel it because it's so small.
You didn't measure it. No, you didn't.
I didn't, but 10 other people did, and all their measurements agree.
No, if you're talking about weighing things on scales, that's not measuring Earth spin.
It's measuring difference in centripetal acceleration.
You're just measuring the weight of something, and then now you're declaring it's because of.
There are because if there's a difference in weight of something, then there's a different force on that thing, right?
No, this is your claim. You're supposed to lead us through the logical, sequence, saying because of this, then that, and reaching the logical conclusion.
Okay.
Yep.
Sorry, I'm reaching my limit here. I have a short attention span here, but
Well, this would be a lot easier if you just wouldn't affirm the consequent each time.
Okay. Here's your flow chart, right? So I get accused. I get accused of this thing would not be possible on the globe, and I said no. If the Earth were a globe, this would be possible. And then I get you're affirming the consequent. No, I'm just saying
No.
that if okay.
Nope, you're already wrong at the very beginning because you want to poison the well. No one here is saying this is not possible on a globe, and then whatever the rest you just said. What you're saying is, what we do is we get numbers. Excuse me. What we do is we get numbers, and then because of those numbers, we're going to draw a conclusion that is totally unrelated. That's what's been on repeat so far.
Can you post a copy of your flow chart you're using so I can look at it to see because I'm sure it wasn't peer reviewed.
No, I'm saying that when I talked about spherical excess on a
no, just excess, just excess, just excess, not spherical.
If you're talking about excess, right? If you're standing on a sphere looking at somebody else, then it
No
was
one's
said,
standing on a sphere. No one's standing on a sphere. You drew the conclusion. If, hypothetically, right?
It was said by two people on this server that it is impossible to optically get spherical excess even if you're standing on a sphere. I was saying
Never seen it.
I was saying no. If you are standing on a sphere, you can get spherical excess, and then I was told affirming the consequent. That happened like 2 or 3 times.
No, again, you just lied. No one said that. What you did is you got excess, right? Somebody got excess, 900-page document, and then somebody affirmed their bias or affirmed the consequent that it must be because they're on a sphere.
No, I'm saying the conclusion I was taking from that data is they took 47 different triangles, all measured at different places across the United States, and every single one gave a theoretical radius of the Earth of about 6,000 kilometers. So I'm saying,
Incorrect.
You know what?
Incorrect.
Okay, we're gonna talk about this for a 6th time now. All right, what is your?
No, we're not going to talk about this again because if you continue to use this hypothetical or this presupposed ball in every argument that they make, we're not going to have this anymore. You're going to go on white mic. You understand? Every time you say excess and then attach it to a sphere, you're just affirming the consequent, and you know you are. You haven't explored every other option. You've just decided that it has to be sphere.
No, I'm saying a very simple explanation is that it's a sphere.
Well, who cares about the explanation that you want it to be? You want that to be the explanation.
Fair enough, and you don't. That's fine.
So
Yeah, what's up?
earlier, you dropped out or something for a minute, and we went through the logical consistency of it, right? And he turned it into modus ponens. So he said, if spherical excess, if excess, then a sphere, excess therefore sphere. To try and get around there, affirming the consequent.
Oh, okay.
If excess, if triangular excess, right? Yeah, and sphere. There's excess, therefore sphere. Turned it into modus ponens.
That's not a logical syllogism. That's affirming the consequent. Formal logical fallacy.
No, so we've also talked about this. That's science. That's a hypothesis. That's a hypothesis and testing a hypothesis.
No, it isn't. You know it isn't. That's not natural science.
Do you need me to make you a flow chart on how to do this stuff? Where you're going wrong? Since you're in here trying to teach people, but it seems like you're doing the wrong thing.
All right. I would like to see. I would like to see your flow chart.
Well, do you have one yet? Because I have Visio open right now, and I'm starting on yours.
If it's not too much work for you, I would be interested to see what you come up for me.
For your flow chart?
Yeah, I would be interested in it.
Okay.
I mean, I don't know if it's gonna take you too much time. I might hop out of here in a little bit because I'm gonna hang out with my girlfriend in a little bit. But if it's not gonna make you too busy, then
Don't tell her that you were getting schooled by other people about engineering.
Yeah, that's.
Okay, so we're starting with what on your flow chart, and then I'll take it from there.
All right, start with the first thing I said when I hopped into the server was things weigh different on different latitudes.
All right, things weigh different on different latitudes.
And then somebody said that doesn't mean that the Earth is a sphere.
I'd need a citation for that statement.
That one doesn't matter anyway. I just need to know what things weigh different at different latitudes. So right there, we can do a whole flow chart on how to figure out if that's true or not. So I'll work on that here real quick. You guys can keep learning about engineering. If you want
a citation,
keep teaching engineering to these guys and how you do truth tables.
I can get a measurement as well.
Well, I don't even think this flowchart will get to that because first thing it's going to do is say take measurements. So we're going to see how far it gets.
Are you guys Wolfie fans? Wolfie
Is that
did it.
software?
No, he's a guy on YouTube.
No, I don't watch guys on YouTube.
Wolfie thinks of something on his
Adam's a
plane
Wolfie
to
fan.
automatically calculate for the Coriolis effect while he's flying. So he doesn't understand it at all.
Yeah, Wolfie thinks that he has to make his path in an aircraft appear straight to observers on the ground.
All right, you want somebody else? You want somebody else to do it? That's fine. I'll find somebody else doing it. What about? Let's see. What about this guy? This guy's got a good one on it. Here's another one. This guy also has he amalgamates all the data that everybody else did and normalizes them for their latitude, and they not only agree that the Earth is spinning, but they agree that it is not perfectly spherical, but instead in a spheroid shape. All right, I'll find some more. Does this guy take any measurements? Let's see. Doesn't look like he's taking any measurements. Let's see if I can find some more measurements here. Here we go. Here's a good one. Oh, no. All right, here's another one. I can post these all day. Okay, so many people have measured a difference in weight with latitude.
And now what?
Now what is your explanation for how things
I'm
weigh
not
different?
making a claim about it. I'm not making a claim about it. Are you?
Yeah, I'm saying that things weighing different on different latitudes supports the hypothesis that the Earth is a globe.
It's not a hypothesis. And supports, okay, so is it proving it? Is it absolute
No.
definitive?
No.
Alright, okay.
It is
thanks.
evidence. In science you don't deal with proof. You deal with evidence.
No, that's silly. That's not what science is.
Okay. What is science?
You can pick either; they mean the same thing.
Hey, was weighing things science?
Just look at the definition. They're synonyms.
Hold on. I got something for him to read. Yeah.
Is weighing things science?
Yeah.
Weighing things is a measurement that you can take as a part of an experiment.
In scientific research?
Yeah.
Okay, great. So at 14 minutes after the hour, recalibrating a scale after moving it is crucial for maintaining its accuracy and reliability. This is particularly important for scales used in scientific research. pharmaceutical, food production, and other precise critical industries. There you go.
Do you know why it says that? Do you know why it says you have to recalibrate it after you move it?
Yeah, because scale companies don't want to be having to explain why things are off every time the user moves a scale around.
Let me ask you a question. If you had a scale and you calibrated it, and then you left it in the same spot for a week, and you turn it back on, would it still be calibrated?
Yes.
It's only when you move it that it's not calibrated anymore, right?
Correct.
Perfect. That's exactly what I'm getting at.
Nope. You're not yet.
Yep, because things weigh different at different latitudes. That's why you have to calibrate it, right?
You said you don't calibrate them, though.
Well, you don't calibrate it because the scale tells you what the mass of that thing is, right? So if you have a 100 kilogram test mass, right, that mass is going to stay the same no matter where you are on the Earth. 100 kilograms at the North Pole is the same as 100 kilograms at the equator. It's the weights that are different, right?
Here's the reason why you calibrated. I posted. Just go ahead and read all that and tell me which ones they made sure that they did all that every time they took a new reading.
Look.
Look. Read those and make sure that when you go back, you ask those guys, you did all this, right? When they say no, say, dude, your results are null and void.
The scale is built to tell you the mass of an object, right? Do you agree?
Anyway, I'm done with that if anybody wants to answer his questions.
Does everybody agree that a scale is built to tell you the mass of an
you'd
object?
have to define mass for me first, please.
I couldn't get past my flowchart because I was stopping here.
No problem. So mass. So, which definition of mass do you want? Do you want the simple definition or the complicated definition?
Physics definition.
Whichever one you're claiming.
Okay. Mass is how hard it is to push something.
Interesting.
Okay. So, the mass of an object is the same at the equator as it is on the North Pole. Mass doesn't change unless you take a chunk out of it, right? So if you have 100 kilograms, is 100 kilograms is 100 kilograms. But the acceleration.
Weight is a convention. Weight is a convention about pressure on a scale in the medium of air. Downward pressure on a scale. It's a convention.
Kilograms?
You're talking about weight. You're not talking about mass.
Kilograms are a unit of mass. I will send you however many sources you want for that.
Yeah, I measure my weight in kilograms over in Australia here. That everybody does.
TB'd up. I think we've talked about this for like 20 minutes before.
No, I'm just saying that everybody in Australia, like, there are barely a set of scales anymore that you can set to pounds. It's all kilograms.
Yes. So if you wanted to measure force in an SI, it would be in newtons. But the thing is, that's not interesting to you because that depends on where you are on the Earth. So you'd rather know how much mass you have.
I'm just telling you that my doctor weighs my weight in kilograms.
Okay, because he
Measures my weight in
assumes
kilograms.
that the acceleration downward that you feel is 9.81.
Doesn't assume shit. He just tells me to stand on the scale and then writes down the measurement. That's all. It's in kilograms.
All right, how many sources do you want? I can post 10 or 100 or.
How are you determining your latitude?
What the case is? Sorry, go on.
How are you determining your latitude?
How am I determining? It's how far away you are from the North Pole is your latitude.
No, but how did they measure it originally, though, so GPS could work?
How do they measure it originally?
Yes. And how you can still measure it now?
They probably got in like boats or something, and they so what they did is they
Indeed. Elevation angles.
They looked
to
at the
Polaris.
stars. They looked at the stars.
And you measure an elevation angle from the surface, don't you? So you're using the surface of the water to measure your elevation angle.
Okay. To measure an elevation angle, you use a line drawn from your eyes that's perpendicular to the surface where you're at. Or parallel to the surface where you're at.
Well, only if your eyeballs are on the sea level, but you just assume we're on a raft here and our eyeballs are at sea level.
No, because the difference
You're
between
using the surface of the water as your adjacent in this example, aren't you?
the difference between your elevation angles of where the horizontal line from your
Can
eyeballs
you
are
answer my
and where the
question
ground
first?
is? Okay.
We are using the surface of the water as our adjacent, aren't we, in this measurement?
No.
You're measuring an elevation angle. That's from the surface.
No.
Yes, that's how it works. You look it up. You use the
Okay.
surface as your adjacent, and you
What do I
cannot
look up?
have a curved
How
adjacent.
do
Therefore, the
I
Earth is measured flat. It is proven to be so.
elevation angle in?
The only correction is if you're standing on a ship, say your bridge is 20 foot above sea level, then there's a height of eye correction, which is sometimes also called dip correction, but that is only to bring your angle down to horizontal. So you are using the surface of the sea to measure your elevation angle. Therefore, the surface has to be horizontal. Therefore, it cannot be curved. Horizontal is no part higher than another, whereas a curve is a rate of slope. Therefore, the Earth is flat and measured to be so. You understand why we are here and why we exist now?
Okay. So the point is, they got latitude and longitude by looking at the stars and every
Measuring
angle.
elevation angles, which
Every
proves the
angle.
Earth is flat.
Okay. All right. We can talk. We can. I'm not an expert in celestial navigation, but I can study up on it for next time. But the point is, when stars go down by 1 degree.
Stop for a sec here. Stop. We need you to tell us what the definition of an angle is. Definition of an angle, please.
Yeah. So it's what Radwin posted. That's how you do it.
So not a horizontal plane then, because your eyes go down to the red circle below. That's your dip correction. So
Yes, but your sextant.
Your eyes go down to the red circle below. Now there's no longer a horizontal plane. So now what do you do?
Your sextant, see, it has that red dotted line, right? That's the level line, right? Or that's the horizontal. Excuse me, that's the horizontal line, right? And you have that angle alpha that goes between that horizontal line and your star, which is the elevation angle of your star.
And you got a big problem when you pick a star that has a ground position that is maybe 3,500 miles away, because that thing is going to be way out in outer space somewhere. Just bizarre. No, it's flat. You're using the horizon as a marker when you're doing this. It's horizontal. It's flat. That's your baseline.
The picture that Radwin posted refutes that.
Yeah, well, if you listen to the fellow that spoke in here a little while longer, or a little bit ago, just a few minutes ago, and he said that you adjust for the dip angle, which is your level above the water. Okay, and you're using the horizon and a horizontal plane between you and the horizon, flat, and then measure an angle. An angle is that between two straight lines.
Yes,
so
that's
what I posted contradicts what you're supposed to be doing.
Because you know that your eyes are above that horizon, right?
Yes, but that's what the dip correction's for.
Right, so you need to bring that down so it's equal with the horizon.
Yes,
line.
but we just talked about elevation angles. That's what an elevation angle is.
What do you mean by when you say dip correction instead of eye height correction? What does dip mean?
Like I said, I'm not a pro in celestial navigation, so I can study on this for next time. But the point is, I was asked how latitudes were officially or were first drawn, and when a star goes down by 1 degree, you've moved 1 degree in latitude, or it goes up. Whatever. It depends on which direction you're looking. Okay. That's the answer. That's the answer to that question. So do we want to talk about how if kilograms are a unit of weight again? Because that's what we were on before, but I don't know. That seems like a funny point to argue.
No, the point is are you using it as a mass measurement or are you using it as a weight measurement? Because those are two different things.
Exactly. So when you calibrate the scale's so you put a test mass on the scale, right? So when you press the tare button on a scale, or when you calibrate a scale, so you put 100 kilograms on it, and you tell the scale this is 100 kilograms, and the scale goes, okay, so I know what the acceleration downward is now. So the scale uses that for future measurements. So you put 200 kilograms on, and the scale subtracts the same value that you got when you calibrated it to give you the 200 kilograms. So it converts that mass of it converts the weight of the mass pushing downward and divides the acceleration to give you the mass of that object.
Okay, so can I be 80 kilograms of mass but only weigh 75 kilograms?
No, because kilograms are a unit of mass. You can be 80 kilograms and weigh 0 newtons.
Can I be 75 kilograms in mass but weigh 80 kilograms?
No, because kilograms are a unit of weight or mass, not weight.
So when somebody asks me my weight, I shouldn't say I'm 75 kilograms?
That's correct.
That's what my doctor writes down.
Yeah, that's your mass. You can ask your doctor next time he does that. If that's your mass or your weight, he'll tell you.
So I go to a job interview and it says weight, and I write 75 kilograms down. Are they,
get hired because you're lying because they didn't ask you for your weight.
Shit.
But yeah, if you wanted to be correct when somebody asks you for your weight, if you wanted to respond in SI units, you would respond in newtons. So you take your weight and you multiply it by 9.81, and you'd say that number in newtons.
What's a newton?
A newton is how hard it is to push something, or how much force you have to accelerate something that weighs 1 kilogram to 1 meter per second squared.
Wow. What's the mass of the Earth?
A lot. I don't know the mass of the Earth off the top of my head.
Oh shit.
When you calibrate your scales, at what point does it ask you to put in your latitude?
It doesn't. So it takes the acceleration. So
What was the barometric pressure at each point also? Because that's very important to scales.
Yeah, if you
That's why they got to
watch the
calibrate
last
them.
video,
If you don't calibrate them, you'll start off wrong when you open your box at a new location. So you need to calibrate them, which you said no, they didn't, because then all the numbers would be the same.
Did you watch any of the videos that I posted?
I've seen them before.
Okay, so you know that they calibrate them for the first measurement, right? So and they
So
record
the first measurement's probably right.
Yep, and they record the barometric pressure for every subsequent measurement, but they don't calibrate it because they want the scale to remember the same acceleration.
That's not how you do things. Sorry. If you want to prove that something weighs more or less in another location, you need to calibrate it exactly the same way you did on the first weight, so that the next one is exactly calibrated the same way. So when you weigh it, it shouldn't weigh a kilogram anymore. It should weigh 0.9999 kilograms or whatever you want to call it, or 98. So unless you know how to do the shit, you wouldn't be able to pass anything in my work. They're going to say, well, you need to calibrate this every time. That'll be the first. I wouldn't even present this without putting that in there.
If you're talking about how many kilograms it is, then you're completely right, because how many kilograms it is not a function of your latitude. That's why you calibrate it.
He's changing latitude. Do they calibrate them or not?
No, in those measurements, they don't calibrate them.
Then they're null and void.
Because they want to tell the difference in weight, not mass.
But is change in latitude the only reason you'd have to recalibrate?
Yes.
No. gave you a whole list of up there. Jostling, misalignment, leveling requirements. They must be level. Consistency of readings over calibration ensures consistency measurement. Calibration drift over time. That's what you were asking about. Ours are calibrated long and shorter periods, and they would lose their calibration over time. To answer your question.
Okay,
And
so
there you go.
Electrical
you
shocks.
say yes. Okay, never
Electrical
mind.
mechanical shocks. Other conditions, changing weather conditions, moisture.
Plain air pressure, on off all the time. Yeah, you got to calibrate that when you move your scale.
Okay.
Dust particles.
So if you start from the equator and go the other way, then you should get the same drift, right? If you should get the same. So if, say for example, if you go from the north to the south, then your scale reading is going to go down. And if you go from south to north, then your scale reading, what you're saying, should also go down. Because of the same variables are there's the same variables.
Well, the numbers should be the same. I calibrated at each location. If my weight that I take with me isn't right when I calibrate it and reweigh it, my scale's broken.
All right. Wait, who posted this? Oh, Adams. I actually we can this isn't going this isn't going anywhere. But I actually did take a picture from an airplane, and obviously these are all like fisheye lenses here, but if you do a lens analysis, you can find out how accurate your image is, which is kind of cool. But
Really? Don't you got to be on the center of your lens?
well, all you have to know is which way that your lens is being distorted, right?
Oh, so I can just pick any point on my lens and use that for my photography, or does it have to be in the center?
Well, you can use it as long as you're aware of which direction your lens is being distorted, right?
I guess if you say so. I use the center of my camera so that shit's all nice and flat. But whatever you guys want to use is fine.
Well, what I'm saying is that here, let me get this.
Did you get a big bumpy shape when you took your picture?
No.
Then you don't agree with these other people who took pictures of the Earth's curve.
Are you talking about the picture that was just posted in live stream voice chat?
Yeah.
These are all fisheye lenses.
So straight regular lens, no fisheye is going to be flat and level then?
It's going to be much flatter than that.
Oh, but there's going to be a curve?
I mean, here's what I did. So I was on an airplane and I took this picture.
Why didn't you center it? Why didn't you put the horizon in the middle of your camera? Why'd you put it up so it has to bend down now?
Well, look, if you take a look on the right hand side, I took a picture of a straight line. I took a picture of a straight line on the top, the middle, and the bottom of my frame and compressed.
Oh my god, he's compressing images.
Well, if you look at the right side, the image where the straight line is on top of my lens compressed.
Exaggerating your lens that you pushed up so the horizon was up at the top.
No, look. Just look for 1 second. On the far right hand side.
I've looked at this kind of shit for almost 10 years now. I know what you guys are doing, or what you think you're doing.
Just let me explain it for 1 second. On the right hand side, that brown line is straight. I took a picture of it. On the top of my lens, it curves upward. Right? This is the opposite direction of the Earth curve that's demonstrated in the other two pictures.
Wait, are you distorting the image or correcting it?
I'm taking the same image I'm taking the same image and compressing it horizontally.
Just one direction, so then it's all fucked up.
Well, if you look, see the straight lines, the up and down straight lines are still up and down. It's just the left and right lines.
Journalism did a show on this, and you can do this with any straight line. You can take a picture of it, and you can compress it, and you can get it to curve and bend and do weird shit. It's a weird effect.
I would like to see if you could take a picture. If you have a picture of a horizontal line and compress it and make it curved. I've never seen that before.
Go look up Jeranism. He did a show on it. Check out his YouTube channel.
Okay, so the last picture posted, right and left. right, the left one is the straight line, and if you click on that little smudge, that's another picture. You can see how it's not a straight line. It's kind of wonky.
Yeah, because so the bottom two pictures are it's that one and then it's compressed, right?
You've corrected it. You've corrected the image.
That what it's showing you is that the things in the first picture are not straight. You can see very clearly the tape measure curves upwards in the first picture, right? That was the obvious one, and when you compress it, it points that out to you, right? But the very bottom of that, no, it's
We're correcting
exaggerating
it
the
to the way
curves.
it should look, right? We're correcting it to the way it should look.
No, you're exaggerating the curves.
Exaggerating the curves, right? Okay.
Yes.
So it's not a distortion. It's not a distortion.
No, it is a distortion, but straight. But if you have a picture of a straight line and you compress it, that will be straight.
How come when you draw a line, a straight line in Photoshop and compress it, it doesn't do what you're saying?
Can you wait? I will do that right now.
We have
Hold on.
Photoshop, or I would do it for you. We don't use that at work.
I will do it. I will do it right now. Hold on. I will open, or I will make a new. Okay. Let's get a straight line. Okay. All right, 1 second. I'm not skilled in Photoshop like the rest of you are. Hold on.
Sounds like you're having an issue already.
No. I'm just trying to make my line here. Trying to rotate it because.
Pick, and then you squash that image.
Well, it's not very interesting if the line is flat, right? I want to make it diagonal to make it more interesting, right?
Here we go. Never mind.
Well, if the line is
don't even do it. I don't want to
horizontal,
hear that you got to do something different than what I said. I don't even want to participate.
I'm making a straight line, but you don't want it to be horizontal because it's not gonna be interesting to you. Because I have a rectangle and I compress it and it turns into a square. Like, of course, right?
Yeah, it wasn't what was asked of you to do.
Okay.
Shouldn't it turn into a circle?
No. Yeah. No, not a circle. Okay. Okay.
Well, he said horizontal line, so why are you changing it?
All right, 1 second. I have your thing here.
Are we making a magic water ball?
Oh my goodness, how do I oh my goodness, how do I put this thing down? Select none.
We're exaggerating horizontal lines which aren't actually horizontal. They're slightly curved, and we're exaggerating them so that it shows.
With a computer program.
Well, how else am I gonna compress a horizontal line?
But if it's
Why are we
exaggerating
compressing it? Why don't we just look at an actual horizontal line?
If
Because
it's
that's the
exaggerating an
argument.
actual curve, but if it's exaggerating an actual curve, then it's not horizontal to begin with, right?
If you're yes, that's exactly right. Okay, I've done it. I've completed. I've rotated a line. Okay. There we go. I will take this. Yep. I will save this. I can make a flat one too. I can make one in whatever orientation you want.
Why are you rotating a horizontal line? Like it's right in the description.
Because to make it flat, it's still flat, right? But I'm compressing it just to show you that even if it's not horizontal, then it still compresses to be straight. Save as untitled on desktop. Save. Perfect.
Then the trick is that you make that line, make it fill up the whole screen. Take a photograph of it. Okay, take a photograph of your screen and then compress it and see what happens.
That's right.
Okay, now we're gonna Now we're gonna transform this. Okay. Please scale. There we go. And we're gonna There we go.
Yeah, that's a very good control. That way you know that if you compress a straight line in Photoshop and it's still straight, you can take a picture of that straight line because you know it's straight. And then you should be able to take that photograph, which is all that you're ever presenting and squishing, and then squish that. Let's see what happens.
All right, let's see what happens.
Get your camera ready.
All right. All right, there we go. That'll do. We'll save that. Untitled 2. Oh, I have to export these, don't I?
Why don't you just go hit print screen and do a
Okay,
screen?
yeah, I'll
share
do
of it?
that. I'll do that. I'll do that.
Why would
That's
you
fine.
do all this saving and shit? Are you writing a book?
Yeah. All right, I got the first one there. All right. Then we have open up the second one. All right, the second one there. Okay, cool. All right, I'll post these for you. All right, pictures. All right, here's the original that I have. Sorry, I accidentally took a chunk out of it there, but otherwise it's pretty.
Fuck?
Otherwise it's pretty straight. Other than that chunk taken out of it. And then I've compressed it. And there it is, compressed.
So I don't believe this is in engineering either because he has a mental problem.
Okay, so what is wrong with this?
If we were at work and I said, "Hey, go to your desk, draw me a straight line and give it back to me," straight horizontal line. I did say straight across from one end to the other.
You want a horizontal line?
And what you did was you drew me a diagonal line, not even touching the ends. One kind of on the bottom, one not touching the top. I would have to let you go. Sorry.
Okay, what exactly do you want so I can make it to your specifications? You want a horizontal line?
Yeah, you don't know how to draw a line?
Yeah, I got you. Okay, horizontal line. Okay, then we're
I'll
gonna.
draw a line for you in SolidWorks.
Okay.
That way you understand what a line looks like.
Okay, it's okay. I got it. I just thought I would make it harder for me, but horizontal line works too.
From one side of the screen to the other side of the screen, okay?
Okay.
A line, just a line. And then you're going to get your camera out and you're going to take a picture of the with your camera. You can shrink it first, but you're also going to take a picture of that line.
Okay. Yeah,
with
no
your camera. And then from that photo, then you're going to play with it and put it through your compression and see if you get a straight line. You can compress your Photoshop stuff first to at least be satisfied that, hey, when I compress this, it's still straight. It's still a straight line. There's no curve in it. Okay. But take a picture of the full line, okay, and then compress the picture.
I'm not arguing that when you take a picture of a straight line, it curves. I'm not arguing about that. We agree. So
then why are you compressing photographs?
Because I'm trying to show you the curve. I'm trying to be transparent and show you how my lens curves images. So if you look at the right-hand side of the picture I posted.
So since your lens curves images, then we can't use your airplane. Got it.
That's not right, because you can see It is barrel distortion, not sorry, it's pincushion distortion, not barrel distortion. My lens on my phone, you can see from the right hand side, the pictures that I posted, you can see that same line that's curving upward on the top is curving downward at the bottom. So there's
Alright,
pincushion
dude,
distortion on this lens.
why is your line so fat? Anyway, that's fine. And you're gonna finish doing what he wants you to do.
I agree with him though that when I take a picture of that line and compress it, it's going to be curved because my camera curves lines.
Okay, so those levels in the pictures that were shown, we know are not curved, but yet they're all fucking wonky and shit in the
That's exactly right.
picture. So we
That's
can't
exactly
use
right.
those pictures.
No, the reason I attach those is so we can use the pictures because we
No,
know
we
how
can't use the pictures.
we use that to know how my camera curves lines, right? The line at the top you can see bends upward.
Why
But
don't
the
you just take
horizon,
a measurement of the land below you from one point to another and get drop over distance? Wouldn't that be easier?
I didn't have a ruler or a theodolite on me at the time. I just had my phone.
Take your girlfriend in the mirror. If she can see it, you'll know that she's not one football field in the air.
Okay, I don't know what that means, but whatever. So
You'll learn.
you can see that my camera bends straight lines that are at the top of the frame. It bends them upward, and straight lines at the bottom of the frame. It bends them downward. So you can see because the horizon is taken at the top of the frame, it should be bent upward, but it's actually still bent downward, which shows that there is curvature in that picture.
Great. So your camera bends things.
But it bends things in the opposite direction as the horizon bends. So my camera distortion was working against the horizon in this picture.
Wouldn't that depend on whether your camera's level or not?
He didn't want to level. He didn't want to level the camera. I asked him that. He wanted to make it off center so that he could play around and try to correct it.
I have other ones where the horizon's in the center, but the problem is it's gonna be more distorted and look more curved. I want to give you guys the best advantage you can have here.
We don't need an advantage. You haven't measured shit.
Look,
Not look.
I had numbers earlier. You guys don't want numbers. You want real life. So I post real life here, but now you want measurements, which are numbers.
Dude, you haven't given us anything but people looking in the sky.
Well, I gave the whole excess talk earlier.
There's no such thing.
So Amish professor, you've posted a picture, and this bench is not level in the first picture. I've shown here that that straight lines compress to straight lines. The straight lines don't curve when you compress them. That first picture shows that even when they're diagonal, when you compress them, it doesn't add curve.
You admitted if you took a picture of that generated straight line, you took a photo of that and then compressed it would bend.
Yes, because my phone adds curve, which I accounted for in this picture.
All lenses are distorted.
It is distorted. Every picture is slightly distorted. That's why you have to analyze the lens after you take a picture. The way that you account for this is you take pictures of known horizontal lines and see if they're bending and where they're bending so you can account for them. That's how lens analysis works.
So no Earth curve.
Yes, Earth curve. I took a picture of it.
No, that's not it.
Why not?
It's a distortion.
No, the distortion for an object on the top of my lens should be an upward curve, but the horizon is a downward curve.
Through airplane glass.
Okay. When an object goes through any lens, it doesn't add curvature to it.
Distortion, like airplane glass.
Yeah, but here when
Like
you
typically
put a
3
pencil
layers of glass.
when you put a pencil into a cup filled with water, right? There's a lot of distortion on that, but it doesn't curve the line. It just moves it.
So you've never seen distortion through airplane glass. Let me show you.
Yeah, I would like an image. And I hope there's going to be like lens analysis too, because I don't want there to be curvature introduced by the lens.
So, you're saying that light doesn't curve when it's refracted?
Oh, light absolutely curves, but it doesn't curve discriminately to make objects that are previously straight appear curved. It curves in a different plane than that. Yeah, like you can do it yourself. Fill a glass with water and stick a pencil diagonally through it, and it's not gonna make the pencil like curve. It's just gonna displace it. Okay, that picture that you posted very clearly has lens distortion. You can see it off the reflection of the glass. What I was asking for was a picture that was verifiably not taken with a fisheye or any other GoPro style lens to show that it's actually the window causing the curvature and not the lens. Silver domain, I was talking about terrestrial refraction through the air, not through glass. I didn't say that horizontal refraction is not possible, because it is. Are you guys? So I want to talk honestly about this, right? I want to try to be as honest as possible.
We're waiting.
I did. I took a picture. I analyzed my lens. I concluded. I even went into Blender to see if I made a scale model what I would expect the horizon to look like, and it's curved.
Sweet. How come it's not curved from the ISS? According to Paul Larson.
So somebody said that it wasn't curved at the ISS. Is that what you're talking about? People say things all the time. What if somebody like does math and says, "Oh, based on the math that I did, picture shouldn't be curved on the ISS," then that's a different story. Yeah, but Amish professor, I'm talking about the things in the middle of the window. Look, that white line at the top, that's where the horizon was in the picture that I took. And in the middle, that looks perfectly straight.
Until you get in the air and the windows kind of flex from air pressure.
What? Windows don't flex because of... those are bad windows if they're flexing due to air pressure. All right, I gotta take off, but it was fun chatting with you
Here's
guys.
something for you to think about then. Since you said there's what's downward force. So what makes the top of water flat?
So water.
What makes the top of water flat?
Water in large quantities is going to
yeah.
reach equilibrium based on the downward force.
What's the downward force?
It's the force that brings things downward.
Which is?
Do you want me to name it?
Yeah.
It's gravity.
Okay. So If I remove the air from above the water turns into a gas. So it sounds like you might have something to think about.
Are you talking about because of like fluid dynamics, like the difference in pressure? That's yeah.
Yep, go think
Can I
about
just
that.
quickly add that his photo from the airplane, he's drawn a straight line through the horizon, but he's going through areas with and without cloud cover. So the horizon's at different heights. So some of it's cloud and some of it's land. So of course it's not going to match the straight line.
That is true, but then you'd expect.
So it's true, right? Yeah. So you've messed around with the photo. It's void.
No.
Done.
No. What you would expect if the clouds were contributing to the difference in height is you'd expect it to be uniformly higher on the right side.
Look, I
and
don't care
uniformly
what
lower
you'd
on the left side.
expect. You made a disingenuous photo. You've drawn a straight line and said, "Look, the Earth's curving." Put it
And
next
then
to the
also,
straight line.
yeah, Anne said you wanted to be honest. So you are just a walking and talking contradiction.
Look when
See,
you,
if I hadn't have pulled you up on that, and you know that you've done it, you wouldn't have mentioned it. And as soon as I've mentioned it, you've gone, "Oh yeah, I know." You would have just tried to sneak it through. What's with the dishonesty? Why'd you have to do that?
That's trying to like add, $2 billion to a bill and get it passed through under something else.
He was going to leave us with it, sneak it through, and go off with a feather in his cap.
I'll repeat it again. If the clouds are what is causing the apparent curvature, it would be the same height. You can see on the left side, you can see it starts to go up, and you can see differences in the height to where the clouds end, right? So it's clouds the whole way, right? And you can see a difference. You can see it curving.
It's not clouds the whole way.
No,
it's
from
patches.
If you draw a line on the unaltered photograph, that's about one third of the way across, starting on the left, right? That whole section on the left side is sky, and the section on the right side is clouds, right?
They're in different areas. That's what I mean. That like some clouds are bigger
just-
than others. Some bits don't have cloud.
You can just look at the cloud side to get a crisp line, right? And you can see that line very clearly is curved.
No, you can't. You can see different things on the horizon.
Yeah,
it's not clear. It's not clear at all.
All right. Well, all right. I guess next time on an airplane, I'll take a different picture. I don't know what to tell you.
Yeah, first worry about how that water is not flat when I remove the air pressing down on it, causing it to go down.
If it turns into a gas, then you're gonna have a.
Tell me why it's turning into a gas. There's no air pressing down on it.
I mean, are you claiming to be the first person to photograph Earth curve from an airplane? No one else has done it yet. So you're the guy. You're the guy who's the first one to do it, even though you've got this dodgy horizon that you've just drawn a straight line through. Come on.
No, there's
Get
pictures
real
of
for a
curvature from
second.
airplanes. I mean, I haven't taken other pictures. I haven't taken the other pictures that I can give you, but 1 second. So I haven't done the lens analysis, so I can't like verify these, but other people have definitely done it.
It sounds scientific. Sounds magical.
What do you mean?
Sounds like something I don't do when I take a picture of something.
What, lens analysis?
Yeah, do you do that all the time?
No, I just did it because I knew you guys were going to scrutinize me taking a picture with my phone and not analyzing my lens.
Oh, there's the Earth curve.
Yeah, I'm saying this is me saying other people have done this. Okay, Neil deGrasse Tyson said one time that you can't see the curvature from wherever, but he didn't. He was just talking out of his ass. Like he didn't actually like do any analysis on that.
Does anybody have the Paul Larson video?
All right, Bong Sao
Planetarium director says at
posted.
250 miles, you're not going to see curved Earth.
Did he do any analysis on that?
Yeah, he did the math on it and shows you.
Amish professor, I completely agree that lenses have distortion, which is why I accounted for that in the picture that I took.
Alright, so what was with saying that it won't appear distorted?
All right, I was given something to think about on my way out like 5 minutes ago. Okay, so listen. Wait, Bong Sao, listen to who? Neil deGrasse Tyson. Okay, yeah. I've seen this video before. Yeah. And he doesn't do any math he doesn't do any math to back up his claim. I've done math before to see if you would see Kreisen curve, and I resulted in a curvature that's greater than the resolvable difference of the human eye. I have also went into Blender and made a scale model, and you can see curvature on that.
At what altitude can you start seeing curvature?
What was that?
At what altitude can you start seeing curvature on your model?
I don't know, like at plane altitude, it's like cutting it close for sure. Like you really can't see it that much lower. Like I would have to redo the math to find out what the difference, because so the metric that I'm using is a difference of 1 arc second, right? Because that's the resolvability of the human eye, right? So I would have to solve for that.
About a ½ inch above the surface. Okay, now one last one.
So the other thing is,
I got a screenshot coming from that video that I just posted. That'll be Paul Larson talking.
You only see 0.1% of the ball.
Here's that red circle that's inside that picture I posted. That's what you see from the ISS. That's calculated.
Yeah. What is it? Let's see.
Yeah, you're seeing maybe just shy of 3% of Earth's surface from the ISS if Earth was a ball.
But even if you were just to see that image, it would still look curved to you.
No, it wouldn't.
Even if you were, yes, it would. I talked to Indio about this last time. If when your horizon is that size, it's going to look curved.
All right, so what? You got 120-degree field of view.
No, it's going to look curved with a lot less than that. I've done demonstrations for him.
All right, I don't think so, and definitely not from an airplane height.
Yeah, I mean, like I said, airplane height's pushing it, but I did the analysis. There is a resolvable Earth curve that you should see on an airplane. I made a scale model in Blender. I saw Earth curve on that one.
Well, why don't you present it?
Yeah, no problem. I can do that. Let's see. Here it is. It's like hard. It's hard to see because I'm not a Blender expert. But the ground is the Earth. The darker image is the Earth, and the lighter image is the sky.
Okay, so let's come back to reality and come back down to the surface. Be measured directly.
Spheres don't look flat. I don't know what that means. Okay. All right. I really am going to go this time, but yeah, it was always lovely chatting with you guys. I'm sorry I got a little bit heated this time just because I repeated myself so many times, but I apologize for that.
Wait, that was heated?
Yeah, I mean, he did for my. I don't. That was the most I've ever raised my voice on this channel.
Don't let it happen again. Completely uncalled for.
Yeah, yeah, no problem.
I'm kidding.
Yeah, no, I understand. I try to be respectful. I understand that there's Globers that come in and think you guys are stupid and yell at you guys, and I don't want to be like that. But, yeah. But it was nice chatting with you guys. Yeah. Have a good day.
Well, you definitely got flat smack. Remember that next time you're coming back.
I will. I'll remember that. Yeah, for sure.
Yeah, take care, man.
All right, you too.
Funny how they just want to argue just for the sake of the argument and not actually see for what it is for, the truth, what's wrong with their fallacious reasoning. So weird.
Yeah, that guy, he seems like a nice guy, but his mind's gone. It's
Yeah,
completely
all of
gone.
his curvature only exists in his models, like the one he just showed us before we left.
What he didn't say was how many photos he took on the airplane before he got the photo that he wanted.
It's funny when you guys that maybe what's that the mainstream narrative, like, Neil deGrasse and all that crap, like they're just like, look, you can definitely see a little bit of curvature from the airplane. It's like, really?
Yeah, and the throw of light from the sun is not going to cast straight edges either. The Terminator is curved.
Yeah, that's what I was thinking. The sun's maybe had some effect on that image, shining directly on the clouds on that side. Also, it looks like there's maybe a mountain or something he's flying over in the middle. So it just points up, just next to the wing.
Meanwhile, we've got like high altitude aerial infrared long range footage from Jay Toland and others, and Dwayne Kellum's high altitude infrared hot weather balloons, and then you have no curvature, right? So sometimes curvature's there, sometimes it isn't. They need to get their story straight.
I think he also got the limits of human vision incorrect, because the average human vision is about 103 arc seconds.
Yeah, and that's not the same thing as your perception of curvature.
Yeah, if you look at a hula hoop's only flat and level at one angle. As soon as you start deviating from that angle, you will start seeing curvature.
Right, because when you're standing in the middle of a hula hoop, it's flat from your point in the radius out to the edge. But on a ball, there's a spherical cap, which means you're curving. This means there's an elevation change from your point in the middle and the edge of the hula hoop on a ball.
And as you go higher and higher up in elevation, you're just basically seeing the edge of a very large circle. Circles have curvature along the edges.
Yep, and so would the throw of light if you could be high enough to see where the sun is casting its light down on Earth.
That's what I told my buddy. He's in the Marines. He swears he saw it from a Black Hawk. And he definitely flew in one because I met his buddy pilot, right? And they say they both saw the curve. And I said, "Well, dude, if we do have a circular edge, which a lot of us kind of, well, there's theories about it, but from the long distance, you could see that with all the crap you learned growing up. You know, it's all it's all kind of like you're ready to see it anyway. But like if you saw a curve from a long way away or a round edge, it'd be very easy to just be like, yeah, I saw the curve. Because I don't think he's lying. He doesn't see, come across as a liar. But I said, I don't think you're lying. I think you believe you saw it.
Yeah, I think they really do believe they see it. I mean, did you know that there's a psychological condition for this? Yeah, it's called the lemon illusion. The lemon illusion is when you see curvature that's not there. I'm not even joking. You could Google this right now. The lemon illusion is seeing curvature on objects that are straight.
Yeah, like he thinks because they were up higher than like airline flights that they saw something that everybody else didn't. Because SR-71s they fly pretty freaking high.
Well, they have an
Gosh, wait,
expectation to
I don't
see
know.
curvature, and then when they think they see something that satisfies or fulfills that expectation, then they think they've confirmed it in their minds.
And plus, those things have that weird window too. It could easily, like, you never. I wouldn't put it past like some of the big aeronautical manufacturers to like manufacture something just so that the guys come down and they're like, yeah, man, we saw. I don't know.
It'd be funny if they did. I'm not so sure about that, but I mean, regardless, like with this guy that came in, we showed him pictures of lens distortion and pictures of distortion from windows themselves, and he kept dish galloping back and forth. Well, that's not it. That's not it either, and that's not what I'm talking about.
Yeah, that would be pretty bad. Well, I guess you wouldn't if it showed something curving it wasn't. Yeah, you wouldn't be able to fly too good, would you? That's kind of a dumb thing to say.
Well, and then he agreed that cameras will distort the image, and make it curved if you compress it and stuff. So he agreed to that, and then he goes, "Oh, but not in my picture. That's not what happened in my picture."
Yeah,
It's like,
I heard that.
how can it happen here, but not, not there? Just you must have had just that perfect camera.
And not with my vision either, even though when you're in an aircraft and you're looking out like 200 kilometers, the human eye cannot resolve an object at 200 kilometers that's 100 meters in size.
I
Human
feel
vision is
embarrassed.
really terrible.
I feel embarrassed I didn't know about this lemon illusion.
Fascinating, right? So with that in mind, let's say you got these Globers, right? They're taking these pictures of the horizon, and they take pictures, and the horizon appears to curve. Do you think that they're doing the honest thing and they're doing the real lens analysis and they're straightening out that curved horizon because they know that the lens of their camera is curving it? No. They're going to present that image and say, look, I found curvature. Here it is. No, I don't have any measurements of any distances to anything. That's what they do all day.
They also don't understand how digital cameras work, where digital cameras in post-processing will actually straighten out curved lines.
What makes a person? I don't know, man. Like when I figured out the Earth was flat and all that crap, I just like apologized to my brother. Like, what makes a person freaking dig in and be like, no, no, I'm gonna go. You're wrong. Even though I just, I mean, I don't know. I mean, once you look into it, how can you not? I don't know, unless they just don't look into it. I mean, once you go to the ISS and you start looking at that, and then you start looking at funny thing happened on the way to the moon, like like it's so clear. Like, I don't know how anybody can be like, nah, I'm just gonna go back and watch NASA. I don't know.
Well,
Well,
it's
if you want
the
to see a flat
paradigm.
horizon, you want to check out the Chinese space station live stream.
Yeah, they got a flat horizon. No, it's the paradigm shift. Like you think of a lot of the people that come here. You think of the things that are fighting, their battle. They come here, and they have all these beliefs, of the things that they believe in, and to just come along and say, you know what, it's all crap. It's all BS, and we can show you. Well, they spend a lot of time learning what they learned, not necessarily that it's true, but they're so invested in it that they can't let it go, and in some cases at any cost.
Yeah, there's a social cost embedded in with all this, right? If you become a flat earther or friends with a flat earther, then you're persona non grata.
And you must be stupid.
Yeah, that's a big blow to people's egos for people who pride themselves on feeling smart. And for a lot of these guys, what's being smart is reading like Popular Mechanics or Futurism.com or any of these big, science blogging and science article websites rather than actually reading the papers and digging into the methodology and assumptions and models that they use. People read the headlines.
Yeah, headline readers. That's a big thing. I use an analogy for that one, where there's a story about this person that jumped off a bridge because they were having a bad day, and then you read this whole paragraph and you feel so bad for this person, and then the very last paragraph in this 10-page story is, but none of this happened because it was just a thought that he had, but he's actually in a good mood and he's having a great life, and he went home to his family.
Wasn't it Popular Mechanics that the Picard story was done in 1915? Wasn't that Popular Mechanics?
Sorry, man, I couldn't hear you. Picard story? What?
Popular Mechanics. Wasn't that the one, the Picard story? And Picard flew the bathysphere up and looked out the window and saw the
You're a little
circular
choppy there.
flat. I'm
Your
sorry.
audio's
Maybe it's. I'm
Yeah,
sorry.
your audio is a little choppy. Maybe you can disconnect from here and just rejoin. Just come back in and try again. Maybe you'll get a better connection. We'd like to hear what you have to say. You can try again if you like.
I'm out. A lot of times people got that good. I was talking about Picard. Wasn't Popular Mechanics the magazine that the Picard story was posted in 1913?
Oh, you mean the hot air balloon guy,
Right.
Auguste Picard? Yeah, I think so. I thought you were talking about Star Trek for a second. I'm like, what? Some of these Globers learn as they go. They talk to us, we school them, we educate them on what they should believe, and during the conversation, they'll suddenly become instant experts on something that they just learned about from us. I think that happened with a guy earlier today. Because he was
No, what
bringing
they
up
start,
the Arc of the Parallel survey.
well, what they normally do is start Googling it once you mention it and they realise they have no idea. And then all of a sudden, after they've Googled it, they're Google experts.
Yeah, and what's really funny is because we've been around a while, we know exactly what websites they Googled and they're parroting. We know what comes up in the search results in the search engines.
Yeah. Yep.
Usually they're going to bring up Mick West or Mick Toon or some other Mick.
I was on Facebook yesterday and they were all using Bill Nye, the fake science guy, and showing the boats going over the horizon.
Yeah, that one's pretty funny and bad.
Yeah, they were using that one on Facebook yesterday, saying, look how stupid you flat earthers are. We learned this in high school. Even Bill Nye shows it. Have a look.
All right, gotta go. I'll be back later. Thanks. See you guys.
An open letter to the Globetards. Dear Globetards, I trust you are doing well. Before beginning, a caveat must be stated to clarify exactly whom this letter is addressed. A Globetard is not just someone who believes the world is a spinning ball flying around in multiple directions at once through the infinite vastness of the theory of space-time. Well, practically everyone in the modern world believes this exact theory, and everyone who now understands the truth was once counted among the very ranks of the deceived. Globetards are the so-called people who spend all of their time with hundreds of sock puppet accounts, trolling flat earth threads and comment sections on videos, arguing to no end for the absurd theory that their ass is stuck to the side of a spinning ball in outer space. Globetards are those who refuse to acknowledge whenever a valid point is made against their religion of scientism. Once you've been introduced to the concept of a motionless planar Earth, yet you refuse to consider this concept or refuse to prove to yourself that the world is in fact a spinning ball, yet you spend all of your time arguing against people who know better, you might just be a Globetard. We should also discuss exactly what it is the deceived must believe by default, whether or not they are aware of said beliefs. It lies beyond the comprehension of this writer how one can count themselves among the ranks of some group or espouse themselves to a given belief system without fully comprehending the basic tenets of that system. As El Guapo says, how can you tell me I have a plethora if you do not know what a plethora is?
Jefe! German arrived yet? Not yet, Guapo. Many presents have been coming for your birthday. German has the only presents I want. Guns! Guns, so that the name of El Guapo will be hanging on everyone's lips. He will be here, Guapo. But I think you will like your other presents too. I have put many beautiful piñatas in the storeroom, each of them filled with little surprises. Many piñatas? Oh, yes, many! Would you say I have a plethora of piñatas? A what? A plethora. Oh, yes. You have a plethora. Jefe, what is a plethora? Why, Guapo? Well, you told me I have a plethora. And I just would like to know if you know what a plethora is. I would not like to think that a person would tell someone he has a plethora and find out that that person has no idea what it means to have a plethora. Forgive me, Guapo. I know that I, Jefe, do not have your superior intellect and education. But could it be that once again you are angry at something else and are looking to take it out on me? Like what, Jefe? Could it be because you are turning 40 today? No. Could it be because Carmen chooses to sleep in her cell instead of with you?
So according to these beliefs, the Earth has a diameter of about 8,000 miles and is a sphere housed in outer space which spins and orbits, etc. The spin alone amounts to some 1,000 miles an hour at the equator, and, well, half the speed is the hour hand on a 12-hour clock at the pole. There is no direct evidence of this disparity in edge velocity on the spinning ball Earth, yet it is assumed as a fact. Another assumption is that light always travels in straight lines when convenient to the argument, yet light bends sometimes, but only when it's convenient to your argument. You believe that the Earth is moving up towards your feet in the morning at 6,600 miles per hour, and that the Earth is moving down away from your feet in the evening at 6,600 miles an hour. a total acceleration of over 132,000 miles per hour, which we should experience constantly throughout every second of every day. You believe that the universe was created from nothing by chance, and that our oldest ancestor is ultimately a rock, or some primordial ooze of natural amino acids, water, and carbon, molecules which randomly organize themselves into complex, intelligently written code, which allows for relatively simple materials to organize themselves out of their own volition into multi-organ systemed life forms, which have awareness, intelligence, and also self-replicate. By chance. The world has thus organized itself around the premise that the omnipotent men of science have concluded by some experiment that our genesis and the genesis of all the hypothetical worlds in space zipping around far larger and more remarkable suns than ours is due to chance and gravity and chaos. Society somehow deems those who read science in a book and repeat science are somehow more scientific or even intelligent than those of us who question what was written in the books, especially should we find a discrepancy between said dogma and reality. And finally, the social media giants, such as the very platform upon which you're probably watching this now, have decided that it is not only foolish and ignorant to question the very nature of the world within which we all exist, they have deemed it dangerous to the degree that they must step in and take action against we foolish flat earthers. I honestly don't believe YouTube could do a greater service to the flat earth movement than to disown it, as they will inevitably force the hand of flat earthers to abandon the quagmire of common social media platforms and migrate over to either smaller sites, which will become future juggernauts, forcing said common platforms towards the way of Napster and MySpace. The globe Earth theory entails one single piece of observable evidence to base its entire foundation, and that is to say that the heavens apparently rotate around Polaris in the north and some indiscernible point in the south. The entire latitude-longitude system is built around observations of the heavens, observations which can be mapped into a celestial sphere, comprising the heavens and setting the foundational basis for the globe Earth theory, where the celestial lights are effectively infinitely distant, or they can be mapped to a celestial plane, where the celestial lights are comparably local. Each assumption requires one caveat statement, that is to say, for the former, that light from the celestial objects must, for all intents and purposes, travel in absolute straight-line paths from the celestial object to the eye of the beholder, or conversely, in the latter, that light will certainly bend when propagating through variable temperature or density media, as shown by multiple experiments. The entirety of the ball Earth argument is founded upon the erroneous and outdated assumption that light must always travel in a straight line path. Globetards love to harken back to ancient philosophers such as Eratosthenes up to Galileo, who would have both been born in an era prior to the scientific acknowledgement of refraction of light, which is a direct factor in fashioning the illusion of curvature, as well as fashioning scores of generations of people devoid of any real understanding of the natural world and the unattainable universe beyond. Anyone who takes the position, the shape of the world doesn't directly affect me or my day-to-day life, so it's not worth looking into, really needs to reconsider their position. To say that it, quote, makes no difference that practically the entire world has a fundamental misunderstanding of the very nature of the world, and thus extended philosophy in many areas, should take a crash course in world politics. America has seen a drastic spike in domestic jobs being outsourced to developing countries, not just because it's way cheaper to pay slave wages to dictators, but also in large part due to the overhead of waste disposal. It may not seem like that big of a deal, but EPA standards for waste disposal are extremely costly for large corporations. Anecdotally, when I worked for a small print shop, hands down the largest single expense the owner had to pay for was waste disposal. Old Mr. Shooter used to get ill when it came time to foot the bill for the waste from the old Heidenbergs to go out. I can't tell you exactly what it was per drum, but I remember the bill one time running pert near 10 grand for a single trip, with several 50-gallon drums being hauled off to probably be processed down into some tradable quantity or the other, or perhaps buried deep in some hole in the desert. Who really knows? And let's not forget the creation of the American Dental Association in order to allow aluminum manufacturers to dump their toxic waste into our toothpaste and drinking water forevermore in the form of sodium fluoride. The point is, our entire world economy and geopolitical structures are founded upon the underlying assumption that life is a freak accident of nature, the Earth is just a speck of dust in infinity, and science somehow has it all figured out. It is the underlying consensus that the layman need not worry himself with the affairs of learned men of theory, the pinnacle of whom is undoubtedly Albert Einstein, who never bothered to correlate his thought experiments to real-world experiences, yet his musings are regarded as scientific fact forevermore. For example, the infamous equation...
The infamous?
E equals mc squared belongs strictly in the realm of pseudoscience, or even under the banner of a fairy tale, as it inherently asserts that which cannot be demonstrated by its very nature. Never will human technology accomplish the acceleration of some bit of matter at the speed of light squared. It is mere conjecture which purports that an object accelerated near the speed of light will experience time differently than an object relatively at rest, nor is there any experimental evidence to suggest that such an object, when, if accelerated to the speed of light squared, would simply become pure energy. In the infinite void of space-time theory, there is absolutely nothing which stands absolutely still, as all matter was birthed from the hypothetical Big Bang, meaning everything is constantly in mind-boggling motion. And of course, the Big Bang is the theory from whence nothing randomly decided to manifest everything in the universe into an area the size of a pinhead, which then exploded and randomly organized itself into diffuse nebula clouds, which by nature cannot exist in a vacuum, then randomly organized itself into stars and planets, and finally self-replicating life forms, which only have the illusion of purpose and uniqueness, but are really just the result of chance, chaos, and some freak accident of natural chemistry. And a bit of luck, of course. For a so-called lifeless planet to have been created by chaos and happenstance is one thing, but to create life on such a place is another. The hypothetical planet Earth is indeed very lucky when you think about it, though. We're just close enough to the sun that our water doesn't remain in a frozen state, just far enough away that it doesn't boil off into gases. Not to mention just the right size for that distance to allow for temperate climates and convenient-to-life liquid waters. Remember, if you adjust the size of a theoretical planet Earth, then the gravitational constant would throw our temperate barometric pressure of 14.9 pounds per square inch out of whack, and then you would have to have a different distance to the sun in order to make that work in our temperate little Goldilocks zone, as they say. Very lucky indeed. And the peculiar fact that the sun and the moon appeared to be identical in angular size to the lay observer, yet we cannot trust our senses in a globe land, for the sun and moon are precisely 400 times different in size, but also precisely 400 times different in distance. Thus, we are presented with the illusion that the sun and moon might somehow be the same or similar or somehow connected, when in fact they are nothing alike whatsoever, and even entertaining such a thought somehow makes one stupider than he was before. Random chance and chaos have, of course, placed the sun and the moon at such unlikely sizes and distances, tantamount to winning some sort of cosmic lottery. But of course, this illusory effect probably happens an infinite number of times in the hypothetically infinite universe theory, so it isn't that big of a deal. But of course, that's not the only amazing coincidence you must swallow in order to humor the globe Earth theory. We are only ever presented, remember, with one single face of the moon at all times throughout all of recorded history. It is proclaimed by globetards that this is due to the fact that the moon orbits the Earth in exactly 27.32 days, but the moon also spins once upon its axis in exactly 27.32 days. This would be way too much of a coincidence when coupled with all the other coincidences we just mentioned we're expected to subscribe to. So the theory of tidal locking was invented to conveniently apologize for this amazing coincidence, which is to essentially assert that the waters sloshing around on planet Earth somehow have the peculiar and unique ability to affect the directional orientation of the surface of the moon some 250,000 miles away, according to them, via the undetectable, unmeasurable pull of gravity. Whenever the theory of gravity is questioned or refuted, invariably the globetards will bring up the astute observation that, were I to jump off a building, I would certainly plummet to my death, thanks to the theory of gravity. Of course, the fact that high-density objects will indeed fall, while relatively lower-density objects will rise above them, are not contested in the slightest by any flat earther. The notion that gravity around a spinning ball is the cause of this natural phenomenon is indeed refuted. The fact is, what goes up must come down is a valid, cogent, and astute observation, which always occurs in nature under normal circumstances, and thus can indeed be considered to be an immutable law of nature. Flat earthers are not in the business of disagreeing with such laws. Quite the opposite, really. What is, however, contested is the notion that objects fall due to the theory of gravity, which fundamentally hinges upon the assumption that the world is a ball, where all nearby matter is attracted towards its center. For some reason, balltards contend that the fact that higher density objects find their natural place of equilibrium relatively lower to the ground than relatively lower density gases or objects is somehow exclusive to a spherical Earth. In contrast, reality dictates that were the world a spinning ball, it would thus be a centrifuge, and the last thing one would expect would be to see this sort of organization of matter. Were you to house varying density liquids in a centrifuge, higher density liquids would find their place of equilibrium further from the center than the lower density liquids. Yet, we're expected to believe that gravity, the weakest of all natural forces, as they say, is somehow strong enough, and let's not forget smart enough, and also undetectable enough to force the opposite arrangement upon the centrifuge Earth, in theory. And pray tell, at what point exactly does gravity cause mass to become attracted to other mass, spontaneously, without any sort of magnetic field involved? Why do we not see gravity with, say, small particles of flour or salt around larger objects all the time, such as bowling balls? And since we do not see such evidence of gravity on the micro level here in reality, how then can science claim that gravity formed the stars and the planets out of diffuse nebulous clouds? There is a conundrum here, and there is always a conundrum when it comes to globe-Earth alliance. And of course, these conundrums cannot and will never be answered by the religion of scientism, so the question is simply avoided, and the dogma of random creation from nothingness is espoused and defended by Team Glotard ad nauseum. And again, we must subscribe to all of these things as being coincidental, with the largest coincidence being the planet Earth, in theory, has life upon it, which is claimed to happen once every, many hundreds of millions of planets, so aren't we lucky indeed to have life? But couple that with all these other assumptions that we must swallow in order to believe in the ball Earth theory, and it really becomes quite unlikely and in fact ridiculous. Finally, we are all walking, talking proof of an intelligent designer, a creator if you will. The notion that our DNA randomly manifests by chance coincidence is patently absurd. Equally absurd is the notion that we are all riding upon the side of a spinning sphere in the infinite theory of space-time in 4 or 5 different directions at once along great curves of hypothetical orbit. The Earth, our home, is, as far as we can tell, the only physical plane of its sort in all of the universe. The entire concept of an infinite universe is not backed by anything but fantasy and theory, and the heavens are, as far as we can tell, definitely not infinitely distant suns housing many potential planets and many potential worlds, but are instead merely local lights, a mere feature of the world itself, local lights above us which circle around a common center, not the Earth spinning around in infinite space. So Globetards, please consider and respond to some of the following facts before continuing with your incessant attacks against our intelligence, sanity, and integrity. Not only is the world perceivably flat and motionless, but every point made supposedly in favor of the ball Earth theory has either been completely refuted as fallacious, or at best can be shown to work under the assumption that the Earth is a motionless plane as well. So for a simplex example, we see the northern stars apparently circle around Polaris once every 24 hours. It can be assumed that we are spinning with our central axis point ever aligned to Polaris, in spite of axial precession somehow, or it can be assumed that we are stationary while the stars apparently spin around the central point of Polaris. Either notion can be humored with varying supporting evidence, but it is only Team Globetard who claims such points as exclusive to their theory. Such pseudoscience and unfair playing is inimical to the sacred process that is the scientific method of discernment, or better still, the zetetic process of reasoning, and is also a disservice to humankind for the remainder of history, until and unless such blatant blemishes in the scientific record are corrected or really stricken altogether. It is also the ballers who claim that ships appearing to go over the horizon somehow proves a ball Earth, when the originators of such evidences were completely ignorant of light's refractive nature, rendering any and all assumptions about distant ships null and void. The flat earthers are held to impossibly high standards, and we're expected to explain every portion of the hypothetical universe theory, which is held in dogmatic fairy tale status by the Globetards.
So you're saying the sun is not 93 million miles away? If that were true, it would take up the entire sky, because it's almost 1 million miles in diameter, you silly flat tard.
Well, but we're not saying the sun is that large. Actually, you're the one saying that.
Okay, well, prove to me the sun isn't a ball some million miles in diameter made up of the lightest gases known to humankind, which are undergoing hot atomic fusion, some 93 million miles away from us.
Well, could you prove to me that the sun is all that?
Well, science says that it is.
And this is the sort of logical fallacy we must deal with when arguing against globe earthers, who often do not even understand exactly what it is they believe. Has anyone traveled to the sun, let alone the practically infinitely distant stars, to verify their distances and to take a sample? No. So how can you tell me that you know the size and the distance, and yes, the weight of stars, which you cannot even verify the very distance or the density of, without just a buttload of assumption and conjecture?
Well, because science tells me that it's true.
Do you understand that science is not supposed to reinforce non-verifiable, non-falsifiable whims of ancients, but is instead supposed to be a process to discern the truth, really based on process of elimination and upon what we can tangibly verify? At the end of the day, it is exactly the opposite of consensus which happens to be the truth of this matter. Those who question what is asserted by the pillars of science are the skeptics, and indeed the intelligent of this conversation, while those who read the science books and repeat what they've read and indeed teach their contents are the definition of ignorant and the polar opposite of skeptical. Our so-called educational system is designed to create a non-thinking, subservient class who do not question authority. If you do not fit into this system, you simply cannot make it in the reality which the ruling class have rigged for us. You may be able to squeak by for a while, but in order to toe the modern line, one must conform to the status quo, keep your head down, work like a slave, and refrain from rocking the boat. On the other hand, should you desire to fundamentally change the world by showing really one person at a time that the world that they've been brought up to believe in is a total lie, which fundamentally affects the way we view ourselves and thus view one another, If a man sees himself as an insignificant accident of chaos, or sees the world itself as the same, it is not really possible for him to see the unique importance of his neighbor, let alone his enemy. The stark fact that our realm is one of paramount importance in the grand scheme of things is equally comforting to the truther as it is frightening to the oligarchy. This is why we see the current redoubling of efforts by social media giants to put the cats back into the bag, as it were, when it comes to certain topics like 9/11 truth and the resurgence in flat earth research and scientific progress in that realm. Let's see just how far YouTube in particular will go to quell the burgeoning topics of fake space and globe earth skepticism. Rest assured, the larger the action taken by YouTube, the larger the reaction by truthers, which will ripple through reality in response. Okay guys, thanks so much for watching this video. I hope that you enjoyed it. If you'd like to help me continue making flat earth content, please consider making a one-time contribution through PayPal to www.paypal.me/themorgile, or a recurring monthly contribution through Patreon at www.patreon.com/themorgile. God bless you guys. Thanks again for watching, and as always, spread the word, spread the world, and peace out, everybody.